And here we go. We have liftoff. Propulsion continues to be nominal.
R68 chamber pressure looks good.
Rolling up. Roger, Atlantis.
Water towers, fly! Yes!
Tango down to nominal.
Flight downside FD off. Bring in FD off. Off. It's orange!
45. Oh my god! Oh my god!
Decollage.
Look at this!
Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane would be igniting in the flare, correct?
Yikes. You dead? We don't need any more of these.
Good afternoon or good morning or good evening, depending on where you are in the world. This is Lon Seidman here with NSF, and we've got a fun one today, folks, because look at that on the pad. We got ourselves a Falcon Heavy and all of the cool stuff that comes with a Falcon Heavy launch. And we got everybody joining us today. So why don't we go through some introductions here, and then we'll start talking about what we're about to see. So let me start off with Max, who is out in the field. How's it going out there, Max?
Hey, how's it going, Lon, and everybody else? You know what? Falcon Heavy launch stages just feel different than most everything else, simply because they don't fly anywhere near as often as Falcon 9, and they are just so special. But things are going well here today so far. Had a bit of a weather scare not too long ago, but within the last hour, because there was a bit of a storm brewing up north of Titusville. But it has since seemed to have died down, and weather seems to be back in the green. So fingers crossed that holds for almost the next 2 hours.
That's right. We've got ourselves a 2-hour window today, so we have a lot of opportunity to kind of squeak through the clouds here if need be. But you're right; it does have just a different vibe. And I also want to bring in Trevor, who's joining us as well. Trevor Sesnick, and this Falcon Heavy is like totally brand new, isn't it?
Yeah, so this is the third Falcon Heavy launch that will be entirely brand new, which is quite exciting. You can see all those shiny cores. Of course, the side boosters today will be recovered, and that center core will be expended. But this is actually, I wanted to bring this up at the start of the show. If it goes today, this will not be the first Falcon Heavy launch on June 25th. 5 years ago today, STPT flew in 2019. So just a fun fact to start off the stream.
And in 2019, I actually went to the ArabSat launch as well, and it was awesome to see this take off in person. It has a very much a space shuttle vibe to it. I think it's just the fact that we've got those boosters strapped on the side, and it's just got that same kind of width to it, I guess you could say. So we will be keeping an eye on things. And Trevor, this is we're going to get hopefully back the 2 side boosters, which can then be repurposed, right?
Yes, that is correct. So both side boosters will be returning to land, LZ1 and LZ2. We're not entirely sure which one will go to where yet. We know that B1072 is the MY core and B1086 is the positive Y core. So that's the side of the vehicle that they are on. And sometimes MY goes to LZ1, sometimes it goes to LZ2. But yes, they will be returning to launch site. And then SpaceX can either reuse them on an upcoming Falcon Heavy mission as side cores, or they can turn them back into Falcon 9s and launch them in the single stick configuration.
And we're going to lose that center booster because they're trying to get this satellite all the way up to the altitude, I guess you could say, that it needs to be at. Is that right?
Yeah, so it's going into Geo minus 566. So that's a very, very high energy geostationary transfer orbit where the satellite will only need 566 meters per second of delta V to raise from the orbit where the rocket will put it into its slot in Geo. So that is a very large amount of energy. So they are needing to get rid of that center core on today's mission.
All right. And we also have some other folks who will be joining us in the second hour. So my good buddy Sawyer will be joining us along with Wade, and I believe Julia, too, will be out in the field. So we've got everybody here today to give you some good insights, hopefully, into the launch here. Now, one of the things we are keeping a close eye on is the weather. And I think I want to toss it back to Max here. Looking at the feed that we're seeing right now, it looks okay to me, but what's it like over there?
Yeah, that's just how the weather can be here in Florida. It can change very rapidly within 10 to 20 minutes. And not too long ago, within the last hour, there has been a storm brewed up between New Smyrna Beach and Titusville, just inland of where we are, into the north. And it was coming this way, and it looked very worrying because a pretty gnarly anvil cloud had formed behind the VAB from our perspective. And the anvil cloud was right on the border for what would be green or red for the range and for what would be acceptable to fly in. In KSC, all of KSC, the SLF, the VAB, and both launch complexes were all in a phase 1 lightning warning, which essentially means no flight, no go, be ready to take shelter if a phase 2 comes into play. But so far, it seems like the sea breeze knocked that one down pretty good, and that one faded. But we are still keeping a very close eye on the weather behind us because that can all change within a period of minutes, as I said earlier. But so far, things are looking good. I have not seen an updated forecast from the 45th Space Wing. Last I checked, it was still holding at, unfortunately, 70% chance of violation. But that updated, but I just haven't seen one. But things seem to be okay for now, and hopefully they stay that way.
Yes, and I guess it's one of those things. Do you look at it as a 70% violation or a 30% potential? And it's a matter of looking at the glass half full or half empty. But I did want to pull up a super chat here from Brian Wilson as we are awaiting the weather outcome here. We've got almost 2 hours left in the count here. Again, a 2-hour window also. So even though T0 is at the end of that timer you see on screen, we could go into extra innings here if the weather is not cooperating. But Brian Wilson here, this might be a good question for Trevor. As a meteorologist and a rocket nerd, getting a Falcon Heavy launch for something I will use daily makes me giddy. This will be the primary weather satellite for U.S. forecasting through the 2030s. So this is a pretty substantial payload, Trevor.
Yeah, that's certainly the case. So this is part of the GOES constellation, which they've been doing a bunch of upgrades to provide, and the constellation provides like advanced imagery and atmospheric measurements of Earth's oceans, environment, and whatnot. So it can do a bunch of things, like it helps monitor even some space weather, helps monitor lightning strikes, and all of this. And with this upgrade that they're doing to their constellation, they're really trying to drastically increase the amount of data that they're gathering. So Sawyer, who will be on later, actually got 2 interviews with people from NOAA about this payload. And one thing that was highlighted in those interviews was they're wanting to go from the old constellation. They were able to take a photo about every 30 minutes to now they can take one at about every 30 seconds. So when you're monitoring these massive storms, that's just a lot more data that they're able to gather. So yeah, this is a pretty cool payload, and not the really boring, like, communication satellites that we sometimes get on these Falcon Heavy missions.
Right, the public really benefits from this. And I was just reading through a couple of like the top lines here that it can do. So as you mentioned, it has what they call an advanced baseline imager. This will be the main instrument for imaging the weather, the oceans, and the environment. Additionally, it's got a lightning mapper, which it can do from geostationary orbit, which is pretty cool. And this apparently is the first type of that sensor that will be launching on one of these satellites. And it's also going to have instruments that monitor the sun and space weather. This is like an all-purpose tool here for all of your weather needs. And we've had so many things happen over the last couple of weeks. We had the Northern Lights here where I live in Connecticut. So space weather is quite important. And as an amateur radio operator now, I got to experience what happens when you get a geomagnetic storm over your house. You can't hear much of anything. So pretty cool stuff. Hey, we got a photo up here right now. This, I think, from Max. You got to see this in the clean room, it looks like.
We sure did. And this event just so happened to coincide also with Starship Flight 4. So we were watching this in the waiting room, trying to not yell and squeal like school children as that flight was going on. But we did, and we also got to talk to some of the engineers and leaders of the program from Lockheed and also NOAA themselves too. But they mentioned a lot of the same things that Sawyer interviewed the personnel with about earlier. But we did very cool experience as always to see a payload this significant and this big in a clean room environment before they end cap into the fairings and then transport to the launch site. Had to get in a full bunny suit, hair nets, even though I don't have any hair, and it's amazing to see this in just an environment so pure, so clean, so pure, I guess you could say.
Yeah.
Because I think they actually went into NCAP maybe 1 or 2 days after we were in there. So, and then it rolled out shortly after. And of course, now it is, of course, stacked on top of the very Falcon Heavy we see on the screen now. Very much looking forward to seeing this one fly.
Yeah, it's quite a heavy payload too. So let me ask you, Max, when we look at these Falcon Heavies go up, I went to one of the launches I mentioned earlier. Sometimes they look like they leap off the pad, but if it has a heavier payload, might we see a little more of Falcon Heavy before it leaves the tower?
Just maybe. I mean, I guess it depends on how much the payload weighs and how that affects the thrust-to-weight ratio. This satellite weighs around, oh gosh, what was it? I think it was around 10,000 pounds. I think
5,000 kilograms.
Yeah, 5,000 kilos. Okay, that's pretty beefy for any rocket to handle. But Falcon Heavy with all 5.3 million pounds of thrust can handle it pretty easily. Obviously, of course, enough with enough propellant left over to support a double RTLS over to LZ1 and LZ2. But Falcon Heavy, it really depends on what the thrust-to-weight ratio is in terms of how quickly it can get off the pad. But more often than not, it leaps off pretty quick.
Yeah, so we're going to be looking forward to, hopefully, that happening in about an hour and 48 minutes. If you're just tuning in, we have a Falcon Heavy on the pad that we hope will be launching in just under 2 hours here. And what we're keeping an eye on right now at NASA Spaceflight HQ is the weather, because right now, as far as our last weather report is concerned, it's about a 30% go, which of course is less than 50%. What we found with SpaceX is that they tend to take a shot and see if they can get it in during the window. And there's a 2-hour window today that goes beyond the T0 mark that is at the end of that counter there. So if they can get it up, they will. And Trevor, they often do that, don't they? They can kind of thread the needle a little bit.
Yeah, that's correct. So we obviously mainly see this on Starlink missions, since there are so many Starlink missions where SpaceX has this big window, and then they're able to choose to some extent when to launch in that. However, the one big difference between these Starlink missions and this mission is they're pretty much able to launch any time in that window. So with Starlink, they have only a few T0s that they're able to hit. So they can only move the launch between these pre-designated T0s, when with this, since it's just going to geostationary transfer orbit, really any time within this 2-hour window, they are able to launch.
So there's obviously not as much precision necessary because it's going to be placed in a spot which is kind of directly above North America here. So they certainly have a little more leeway. And if something happens with the weather, I guess they'll just push to tomorrow.
Yes, that's correct. There's another backup opportunity tomorrow. And I should slightly clarify what I said. They can adjust the T0 to be anywhere within this window until they start fuel propellant load. Once they're into propellant load, which for Falcon Heavy starts at T-minus 50 minutes, then they're unable to move the T0 around, and they're fixed into that T0, just like we see with Falcon 9 missions.
So that'll be a very consequential moment when we go for propellant load. And they tend to, at SpaceX, kind of load and go, right? So the fueling is pretty close to the launch time.
Yeah, so Falcon Heavy is no different, where fuel load should wrap up about in the final 2-ish minutes before launch. So they're not leaving much time they're not letting the vehicle be fully filled for that long.
So it is going to be fueled just briefly, enough to get it lit up and off the pad. And I got a question here from one of our regular super chatters, Musical Wolves, Was wondering if Falcon Heavy could fuel as fast as Starship, how long would it take to complete prop load? I know we were talking quite a bit about that during the coverage we had of Starship because they really have upped the velocity of their plumbing. If they were to fuel Falcon Heavy this quickly, how much time do you think it would take?
It would take about 15
Pretty
minutes.
That'd be pretty quick. So
Yeah.
and by the way, a lot of rocket science involves high velocity plumbing. In case you were not aware of that. Hey, Max, one of the other things about the Falcon Heavy that fascinates me is that the center core is very different than the boosters insofar as that it has to absorb much more stress or be able to deal with much more stress with those two boosters strapped on the side. So this center core can't do much else beyond being a center core.
Yeah, that's correct. And that's unfortunately why they have to be expended nowadays, unlike the first 3 Falcon Heavy missions where they tried to recover the center core. It has to deal with the loads and pressures put out from both side cores into it, and that's why it suffers a bit of a weight penalty, even though it is missing grid fins and landing legs, simply because it needs a bit more enforcement around the lower and upper connection points from both side boosters. And then because of that, it just doesn't perform as well or burn as long normally as the side boosters, but they tend to throttle down the center core not long after liftoff to let the side cores do a majority of the work up until booster separation, and then they can throttle the center core all the way up and actually speed up quite rapidly because those side boosters did a ton of work. But yeah, we don't think that they will return to trying to recover the center core anytime soon, simply because of how difficult it's proven to be, and also the performance hit you would have to take in order to do that. So for now, it looks like the center cores will continue to be expended, but that is why it looks so different. Also, it has a white interstage as well compared to the normal Falcon 9s, which have a black interstage. And also a fun note, essentially the side boosters are essentially just going to they essentially are just normal Falcon 9 boosters, and they have been converted into normal Falcon 9s before, and vice versa more than once. Actually, the Falcon Heavy, the expendable Falcon Heavy that launched the Viasat 3 mission, which expended all 3 cores. One of these side boosters, I think, had flown 8 or 9 times as a Falcon 9 first stage before being converted to a Falcon Heavy side core. So a lot of uniqueness in terms of how they can modify and change the boosters that make up a Falcon Heavy.
And so it's a very versatile system. Go ahead, Trevor.
No, I was just going to say one slight addition to that. We actually do know of a mission coming up where they're going to recover the center core. The Viper mission that they're launching for Astrobotic, a SpaceX VP has said they will be attempting to recover all 3 of the cores. So it seems like it's not completely dead, but there's certainly these missions are very few and far between.
We don't see as many. I'm guessing it's just the size of the payloads these days, but really there haven't. These are events when we have Falcon Heavy going up, Trevor.
Yes, I mean this is only the 10th Falcon Heavy launch, right? So we've had more Falcon 9s launch in a single month than we have Falcon Heavies launch in all time.
That's so strange to say. That is so strange.
Somebody asked me, what do you do with these streams you do? I said, it's kind of like sportscasting, but for rockets. And it's very true. We have all the stats, and it gives you an idea as to just how rare this event is. Hey, I want to thank Ali DeMercy for gifting 50 Red Team memberships to other members of our community as we count down the minutes here for the next Falcon Heavy launch. And thank you very much for your support. We'll have a few other folks to acknowledge in a little bit here. And am I wrong, Max? Does this Falcon Heavy look a little taller than usual? Or am I just seeing things?
It might just be the light and the angle. Falcon Heavy essentially has the same height dimensions as Falcon 9 does because it has the same length of first stage boosters and also second stage, and the fairings are identical as well. So, yeah, it might just be the angle and the light.
I have to get this question out of the way from the chat from Soul Productions. Are we stubbying today, or are we going with a regular nozzle?
Oh, man. No, we are going, as far as we are aware, Falcon Heavy will only be utilizing the full-size second stage nozzle simply because of the performance needed in the first place to get the payload to where it needs to go. And that's why they also need a Falcon Heavy in the first place because of its size and weight and the performance needed. So looks like it will be a full-size second stage nozzle today.
So
Thank
there
gosh.
you go. It is no stubby is the final answer. So the answer is nay. Nay on the stubby. Trevor, what's the trajectory today?
Yeah, so since it's going to geostationary transfer orbit, again, Geo minus 566, like all of these missions, it will be going due east out of the Cape. As you can see, it's just going to fly right east, which is somewhat unfortunate if you're in southern or northern Florida that you won't be able to see it quite as well. And then you can see here that the orange shape downrange, that's going to be where fairing recovery will be. And fairing recovery is going to happen about 1,500 kilometers downrange, so it's a ways down there. And then again, both side boosters will come back and the center core will remain expended.
Interesting. And I hear from Alex in the back channel that the fairing is smaller than B14.1. So there's a slight difference there as well. How do they retrieve that? There's a boat out there waiting?
Yeah, so SpaceX's boat Doug is all the way down there, and then about 45 minutes or so after launch, those fairings using parafoils make a soft splashdown in the ocean, and then they just kind of float there, and then they bring up this boat to them, pick them up, and bring them back. And SpaceX has had tremendous success with this wet fairing recovery program. Right before this, they were trying to catch them. I don't know if you
Right.
remember.
I remember that. Yeah,
Uh,
the big net on the ship and it didn't work out.
yeah,
Did it?
Miss Tree and Miss Chief.
Right.
And they maybe caught like 4 or 5 fairing halves. It was very, very few. So they're now going to these wet recoveries, and we've had fairings fly up to 20 times now,
Wow.
with turnarounds of under 25 days, so about 3 weeks. So yeah, fairing recovery is quite the impressive program.
Max, this saves a lot of money to recover those fairings.
It sure does, and reusing any part of a rocket saves a ton of money, and that's where Falcon 9 and Falcon Heavy have really come into their own over the last 3 to 5 years. Is how much they've been able to recover and refly whole boosters and particular parts of the rocket, meaning engines, fairings, legs, grid fins, almost everything. And I think also, Trevor, do you know how much farther downrange they are today to recover the fairings? Because last I checked, it was pretty significant.
Yeah, so a typical mission is about 600. A typical Falcon 9 mission is about 600 or so kilometers downrange, 6 to 700, and this is 1,500, so more than double.
And they'll be in the air for 45 minutes, I think you said, which is
Yeah.
bonkers.
Very long flight down. And I'm surprised that I guess, the net, Trevor, was because they wanted to keep it out of the water, but I guess the salt water in short duration is not as harmful as they may have once thought.
Yeah, so SpaceX made a number of changes to the fairings for this. We know one of their big concerns originally was SpaceX has this like sound dampening foam inside of the fairings, since you want the acoustics for all these really expensive satellites to be controlled, and the salt water would originally damage that foam. So I think SpaceX spent some pretty significant time working on the fairings to make it so that water wouldn't be a big problem for that foam. And also, as part of that, we saw some minor modifications to the fairings. So you can't really see it from this view that we have right now, but along the fairing halves on the top where they connect to one another, there are a bunch of vents. And those vents are so that as the vehicle goes higher into the atmosphere, when the atmosphere becomes less dense, the atmosphere inside the fairing can just be vented out. But that's obviously somewhat problematic when you're on the ocean surface, since you don't want water to go through that vent. So they used to be kind of spaced like radially around the fairing half, and we saw them all get moved to just the edges so that they're as far away from the water as possible. And then I'm sure they've made a bunch of other small changes to the fairings, but yeah, with those changes, they've been very successful with recovering them. I think at this point, they're probably recovering something on the order of 98% of fairing halves, maybe a bit more. and well over 90% of fairing halves that they fly these days are flight proven. So it's been a good program.
Yeah, it's tremendously good. It's one of those things that people don't often think about, but it brings down the cost of spaceflight tremendously to be able to do that. So we have a weather update from SpaceX, and it's an update that doesn't tell us any new information beyond what we already knew, which is that we are still at a 30% favorable weather situation for liftoff. So we are working with a 2-hour window today, so we may see them adjust the T0 time as we get closer to the end of the count here. So it looks like, though, SpaceX is still moving forward here and planning to lift off. And Max, you're there. So what does it look like to you on the ground?
It's coming on in waves. For a majority of the day today, during this morning, during camera setup and setting up for the stream, and then also setting up cameras near the LZ, while it was very, very hot, the weather itself seemed okay. The winds were not awful. If there even was, I think it was just a breeze, and just various scattered clouds around. But as I mentioned earlier, we had that storm wash through just to the west of us inland, which has since dissipated. But right now, again, it's looking great. We have a ton of blue sky. That the skies look a lot more welcoming, especially to my left, to my right, pretty much almost in every direction except directly to my west, where I am seeing a bit of high altitude clouds, which look like they could turn it into something nasty, but that's just how the weather in Florida goes from time to time, especially here in the summer. But for now, things look to be trending in the right direction, and hopefully the sea breeze continues to keep things going that way.
All right, so we'll be optimistic here that we may get the 30%. And Trevor, I've seen them launch in these situations before where they get to the T0 mark or within the window, the weather looks good, and they just punch through that little threaded needle.
Yeah, for sure. And again, like you've been saying, they have a little bit of wiggle room with that T0. They have the full 2-hour window. And the decision point for propellant load is at T minus 53 minutes. So it's about 40 minutes from now. And that will be when we have a better idea of if they're still targeting the opening of the window, and if they're not still targeting the opening of the window, when in the window they'll be targeting. So they do have, by being able to move the T0 around, they are able to kind of find the needle in the weather.
We'll keep an eye on that. And of course, at this time of the year in Florida, poor Max is out there. It's pretty hot, isn't it, Max? It gets hot there in June.
It sure does. Well, that's just how it is in the summer and most of the year too. But especially around the summer, the sun can get pretty brutal. So it's critical that we all find enough shade and of course, stay plenty hydrated in these conditions as well, because the heat can be really, really taxing on everybody here.
It's hot and it's humid. So like in Arizona and maybe parts of Texas, you got that dry heat, but there it is hot. So
see, everyone loves to dog on the wet heat and dry heat. Dry heat, that matters. That really matters because anything below 80% humidity here is dry, at least for us. And everywhere else, if you're above like 40 or 50, it's too wet. But like anything below 80 here is great. I'm not exactly sure what it's at now. It feels decently nice, and that breeze coming out of the southeast is certainly helping a little bit right now. But it is a scorcher today.
And that heat combined with that humidity and the fact that you've got ocean interaction and everything else leads to these very localized weather patterns that can either make or break you. And that's one of the things about Florida. You get these massive deluges and then it's sunny again. So we'll just keep an eye on the weather here as we approach the 1 hour and 30-minute mark to T0. But remember, we have a 2-hour window today. And if you're just joining us, we are NSF and we are covering the launch of Falcon Heavy, and this is essentially a brand new rocket. Both boosters and the center core are all new. And what will happen a little bit, hopefully, later this afternoon is we will see the launch of GOES-U, which is a weather satellite that our weather agency here in the U.S., NOAA, is sending up in coordination with NASA, and it's going into geostationary orbit. We will see the 2 boosters on the side come back. It is always awesome to be around when that happens. And then the center core is going to be expended due to the payload and how far into orbit it needs to get. So the center here will make its debut, and then it will splash down. Trevor, what happens to that center core after it hits the water? Somebody was wondering about that. Daniel was wondering about that in the super chat here.
Yeah, so it's just like a traditional rocket at this point, where after stage separation between the center core and the second stage, they're not going to do anything with it. So it's not like with Super Heavy on these recent Starship launches where they're trying to do a soft ocean splashdown. Uh, no, it'll be basically empty with propellant, and it will just crash down in the ocean and probably blow up at some point during reentry. So not all that much happening with it.
Except the explosion at the end, which unfortunately we will not be able to see, but everything else will be on our cameras here as it goes. And Trevor, I experienced the amazing event of watching not only Falcon Heavy launch but have those boosters come back. Does it ever get old for you, Max, to watch those boosters come back down not far from where you are right now?
No, never. It really never does, and it never.
I think we just lost Max there. As we wait for Max to come back.
Hey, do you got me? There we go.
Got you now. Looks like it a little
awesome.
There. Good.
But no, what I was just saying is that the magic of the physics and motion that you are witnessing with your eyes never ceases to amaze. Just simply because you are seeing two building-sized boosters just completely turn a complete 180 degrees and fly all the way back here to Cape Canaveral. And those sonic booms slap you in the face every single time. And I'm a little bit jealous of where Sawyer is going to be watching from today, because he is only about, oh golly, I think he's only about 2 miles away from the LZ. So he is going to get absolutely slapped with those double sonic booms from each booster. Well, technically triple, but two of them are very close together and sounds like double. But anyway, no, it really does never get old. And also the sound of Falcon Heavy compared to Falcon 9 is extreme. It's difficult to describe with words, but with us being on the roof of the hut over here at the KSC press site, for a normal Falcon 9 launch, the roof does always vibrate a little bit, as it does as well with the Atlas V, more so with Falcon 9 simply because it's a little bit louder. But with Falcon Heavy, everything shakes on a level that is honestly alarming. And that just gives you that it is a stark reminder of just how much more performance you are dealing with here with 3 Falcon 9 boosters strapped together. And I can only feel sorry for LC-39A for having to try and contain all of that for a few seconds. I mean, that pad takes a beating every single time Heavy flies.
And it's been taking a beating throughout its history too, right? Because we were going to the moon from that pad at one point in the 1960s and 70s. I actually happened to meet a reporter. This is at the launch of STS-135, gosh, almost a decade ago, maybe over a decade ago at this point, when everybody came to watch the last space shuttle flight. And this gentleman worked for, I think CBS or one of the major networks. And he told me about how the roof of one of those huts that they were using caved in on the first Saturn V launch. It was that powerful from 3 miles away. So they had to reinforce the roof. And thank God nobody was on the roof when it happened. So it's a lot of power that we're dealing with here. Trevor, how much more power are we talking about? Is it really Falcon 9 times 3, or do you lose a little bit of efficiency?
No, so it really is Falcon 9 times 3 at liftoff. So this was actually an interesting post that we got on X this morning from John Edwards, who is the VP of Falcon launch vehicles at SpaceX. And he was talking a little bit about the mission profile that Falcon Heavy has. So off the pad, right, all 3 of those cores are going to be at 100% thrust. But then very quickly, they throttle down the center core to, he said off the pad, by the way, at 5.2 million pounds of thrust, or 23 meganewtons. So that's a lot. But then right off the pad, they throttle down the center core to 43% was the number he gave us, which was substantially lower than at least I expected. And the reason why they do that is because they want the side cores to be the ones doing the majority of the work for the first portion of flight, so that they run out of propellant first, so that they can start the boost back early. So then what this allows them to do is, once those side boosters have run out of propellant and are separating, the center core is still somewhat full. And that allows them to then throttle up the center core. And basically you have a half full center core that's starting off at, several hundred meters per second and several hundred or several kilometers in altitude. So that's the mission profile that we're going to see. But yeah, off the pad, all 3 cores at 100% thrust, and right, 2 of those are just a Falcon 9, and then the center is a slightly modified Falcon 9. So it really is 3 times the thrust of a Falcon 9.
You think about all the calculation that has to go into that, and I think back to probably the most exciting launch that I've witnessed from a streaming standpoint, which was the test flight of Falcon Heavy when they, of course, launched the Tesla into orbit. You couldn't have a better show than that. It was amazing, right? It was. I actually rewatch it every once in a while when I need a pick me up because it's so fun to just watch everybody react to that. Um, the fact that that worked so perfectly on the first shot and how much calculation goes into that is pretty amazing. John Edwards, Edwards 345 on X is definitely a good account to follow because he does give a lot of neat trivia here that we don't often hear about from SpaceX press. So good stuff on that front. So here we are about an hour and 24 minutes from the launch of Falcon Heavy with the GOES-U weather satellite. And Max, I see a very large tower there next to the existing launch tower. Is that for future Starship launches?
One thing that seems to be glazed over a lot, especially compared to what's happening in Starbase now, is that Starship will eventually be coming here to Florida in some capacity, whether it be 2 or more launch pads at various locations around the facility. That is all to be determined. But yes, Falcon, excuse me. Good Lord, that's already launching from here. Starship will be coming here eventually, and it will be flying regularly once it is certified for commercial service. And that tower is there, and work has basically been stopped to a halt on that for largely the last year or so. But we saw just around Starship Flight 3, I think on the day of or day before, they began working on and tearing down the orbital launch mount legs. So what that might entail, we aren't exactly sure yet, but we will sure keep our eyes on it. But yes, that is a Starship tower here in Florida, and that will hopefully be seeing use sooner rather than later because we are getting quite impatient over here.
Yes, and that's
We
also a
did
big
get
part.
the
Hi, Jerry.
Sorry, I was just going to add, we did get the interesting bit of info from, right, Everyday Astronaut has been releasing his Starbase tours that he did with Elon earlier this month. And an interesting comment that Elon made during that is that the pad is undergoing basically a complete redesign. And that's why they tore down those legs and are scrapping the launch ring that they had built for the Cape. But it was interesting. He was saying that he didn't think that the redesign was necessary, but decided but his team really wanted to do it. So certainly some interesting stuff going on. But yeah, hopefully, Max, you'll get some Starship action there sooner than later.
I mean, with that redesign, it's better to be safe than sorry, especially with a vehicle as powerful as Starship in such close proximity to a facility that does launch NASA and private astronauts into orbit. So hopefully that means they're also designing a certain flame trench to efficiently divert the exhaust into directions that will not completely obstruct or destroy the surrounding environment. But
Sounds like they are, yeah.
Yeah, but better safe than sorry.
Certainly learned a lot from what went on in Texas. I don't know if we can go back to that wide shot that we had on before, but I think that also illustrates just how much bigger, there we go, how much bigger Starship is going to be versus Falcon Heavy. Granted, we have some different angles here, but that tower is substantially higher than the tower that Falcon Heavy stands next to right now.
And also, mind you, the FSS and Falcon Heavy are both sitting up on the original concrete ramp that was built for the Apollo program and the Saturn V and mobile launch tower. Which is about, what is it? Trevor, do you know off the top of your head, is it around 60 feet off the ground?
Ooh, I'm not sure.
Well,
It's pretty high.
It is decently high off the ground, and that was constructed to build and construct a flame trench without having to dig into the ground in Florida because the water table here is very, very high, and digging into the ground would be very, very difficult. But yes, that even though that tower does look small, it is also elevated some feet off the ground due to sitting on that concrete hill. So it's bigger than it looks.
Yeah, for sure. So it's going to be, I think, quite a great way to, I think, once we have 2 rockets on the pad next to each other to illustrate the size differences between this generation of SpaceX rocket and what's to come. So it'll be exciting.
You know what else is crazy in that wide shot? Right, Falcon Heavy was for a brief time, actually a fairly long time, the most powerful operational rocket. And now, of course, that's Starship if you count it as operational. And Falcon Heavy looks tiny compared to the Starship tower.
Yeah. It's crazy. I mean, it's really crazy when you see. I mean, you can see it even here in this shot here, just how much taller that tower is, and Starship pretty much goes to the top. So it's
Yeah.
it's amazing. So it'll be it's gonna be. I'll tell you what. If you are not subscribed to this channel, you should definitely do so, because there will be some amazing stuff happening in the very near future, because presumably we will have Falcon 9 operating kind of in concert with Starship as they continue to work on the project here. So it's going to be exciting, especially as we get into Artemis 3, because this is where they'll be launching the lander. This is where they'll be likely launching all the fueling missions that are needed to get that lander to the moon. So there will be a lot of activity here in Florida, which is why that tower is going up there. And speaking of the Space Coast, Bloodwolf 97 just moved to the Space Coast and is working for Starship Grumman 2 weeks ago. He's heading to Jetty Park to watch his first launch, and it's a heavy. Oh, that's a great first launch to see. So that's going to be excellent. And Max, you've seen how many? Have you just lost count of how many rocket launches you've seen? You keep a list.
I would sure hope not. I actually keep a checklist of every single launch I've seen, and I believe the count right now is almost at 180, with about 50% scrub rate before I moved here. So, yeah, I'm around 180 launches, and we'll hopefully be at 200 sooner rather than later. Even though, with the cadence that's happening nowadays, that shouldn't take too much longer. But yes, I've been fortunate enough to see around 180 flights at this point, and whoever is coming out to watch launch today, whether it be out at Playa Linda Beach or somewhere in Titusville or Jetty Park near Port Canaveral, hopefully everyone has a great view, and hopefully this weather holds off, which so far, fingers crossed, knock on wood, knock on something,
Right.
looks to be okay so far.
And Trevor, really, when we look at the weather here, because Florida weather at this moment in time is very localized, at least based on what we're seeing on the weather radar from earlier, really what it comes down to here is it's 30% at the T0 mark. And it doesn't mean that it's 30% for the whole window, in the sense that you could find a period of time in the window where you can kind of punch through that weather and make that 30% a launch opportunity.
Yeah, so it's 30% for basically the entire window of chances of being go. But of course, since you can kind of move that T0 around, you can have it be what feels like more than 30%. But officially, it is 30% for the entire window.
And that is where we are at. And SpaceX just recently posted an update where the number has not moved from 30%. But if you are just tuning in, we have seen Falcon Heavies and other Falcon launches happen within those weather guidelines there. So 30% doesn't necessarily mean 0% chance of launch. There's just a good chance that the weather might prove to be a problem as we work our way through the count. And Trevor or Max, I'll toss this to Max as our person on scene there. I don't think they would be fueling the rocket if there was a risk of lightning during that process.
Yeah, that's correct. And one thing that they have to look out for is the weather green at any time of fueling, because otherwise, obviously, you cannot fuel a vehicle when you were under phase 1 or phase 2 conditions, as that was way too much risk to the launch vehicle and the surrounding infrastructure. So should something go upside down in a very explosive way. But for now, I mean, we are coming up pretty rapidly on that time. Not too long from now, about 25 minutes from a potential prop load. So we should know relatively shortly whether or not they're going to push for the 5:15 window opening.
Trevor, as you mentioned before, the fueling kind of locks you into a T0 moment. Is that what I heard?
Yeah, so with the Falcon family in general, once SpaceX begins propellant load, they are locked into that T0. That's unlike with Starship, where with Starship, they have about 30 minutes of wiggle room that they can hold at that T-minus 40-second hold point. But Falcon, the propellant is so cold, there's way more surface area compared to the volume that you lose heat quicker. And I imagine all of those factors make it so that they do not have any wiggle room in that T0 once they're into propellant load.
All right, so we will keep an eye on when fueling begins, if it does, to get a sense for this. But we are still counting down. The count is active. SpaceX, of course, is doing all of their pre-launch activities. So at the moment, even though the weather is 30%, they are still pushing forward within this 2-hour launch window for GOES-U. And if you're just tuning in, this is one of those rare opportunities to watch a Falcon Heavy lift off the pad here or over there in Florida, because I wish I was in Florida. Max is there getting some getting some sun and heat right now as we are waiting for news on the T0 time, which at the moment we assume will be 1 hour and 15 minutes from now. This might be a good opportunity, Trevor, to kind of look at the payload again. So this is the GOES-U weather satellite.
Yeah, so this is one of the upgraded satellites in the GOES constellation. So the GOES, by the way, stands for Geostationary Operational Environmental Satellites. And that's part of NOAA's GOES-R series, which delivers high-resolution imagery, providing like enhanced data imagery of weather patterns, severe storms, hurricanes, even some space weather stuff. So this whole constellation upgrade is just NOAA trying to get even more data out of these satellites. So one area where that's very noticeable is they're trying to go from being able to deliver an image every like 30 or so minutes to like every 30 seconds. So all of this should be huge in our understanding of not only weather down here on Earth, but also weather in space. So like you saw earlier when we were showing the lightning map and weather map around the Cape, all of that is powered by satellites like this. So hopefully this will make said predictions and said models even more reliable.
So you could have a situation in the future where it's maybe not such a round number. It could be like 37.8% chance of launch versus just 30. If you have more data, you can make a more precise measurement here. But right now, it's looking like blue skies, at least at the launch site here, as we are getting closer to the 1 hour mark before T0. So, Max, at this stage in the count, what is SpaceX doing, and what's different about how they prep for Falcon Heavy versus Falcon 9?
Well, in the count right now, they, as SpaceX has said before, they are keeping a very close eye on the weather right now, and depending on what the weather is trending towards, will directly influence whether or not they pull go for prop load. Because once they pull go for prop load and start fueling propellant into Falcon Heavy, they are committed to the T0 that is ahead of them. So at this point, if they do get the go, they will begin a propellant load around T minus, what is it? I think 51 minutes or so for Falcon Heavy. And that will take a little... 50, okay. It takes a little bit longer because, of course, you have 3 cores to fill up this time as opposed to just 1 with a standard Falcon 9. So those steps in the count will hopefully be coming up next, and they are approaching rapidly.
So we're going to keep a close eye on this because our first milestone, which will be that go for prop loading, will be happening around there. And then once that go is made, they are committed to it. So that will seal our fate to some degree. And we'll see what happens here. So, so the clouds are coming and going. We saw some weather radar earlier of storms kind of forming and blowing off to the sea. So we'll just wait it out and see what happens here. But in the meantime, we've got a brand new, shiny Falcon Heavy on the pad, and we will see those 2 boosters come right back to near the launch site over at Cape Canaveral. And one thing, Max, that I've noticed is that when we saw that first test flight, the boosters came down almost simultaneously. There was a bit of a gap between the landings, but now there's a larger gap.
Yeah, there is, and it's kind of a shame because we really used to look forward to those simultaneous landings, and that, of course, there's many variables, of course, when you are that high in the atmosphere and the boosters are doing what they do at the velocities that they are at. So there are many factors that play into them coming down simultaneously or not. The last handful have not come down simultaneously, and I suspect this will be no different. But to be honest, you never know. And with the first Falcon Heavy launch on the demo flight, them coming down simultaneously was not expected, nor did they really think that they had no idea that was going to happen. That wasn't even forethought, at least for those of us on this side. But the fact that happened at all was spectacular. Whether it be intentionally done now that way to avoid risk of the boosters either colliding or something going wrong down low, I don't think we know the answer to that. Maybe we will get lucky and we will get simultaneous today. But given the last few Falcon Heavy flights, I doubt that's the case. But you never know.
This
And
is
Trevor,
actually
when
another thing that we got some clarification on from, I can't remember which VP of SpaceX it was on X, but they were noting that uh, it's generally just slight performance differences of the two side cores that determines this. So for the last two, there have been more substantial performance differences. So that's why we have sometimes it's like 10-second or so delay. But my understanding was actually after Flight 1, Falcon Heavy Flight 1, they wanted a little bit more of a delay than they had because they were a little bit worried about, I think it was if the radars would conflict or something like that, like maybe one booster would think its data was coming from the other. I can't remember the exact rationale, but that was something that they were worried about and wanted to slightly increase. But it sounds like they didn't need to actually do anything to increase it. It just sometimes happens from these slight performance differences that occur during, the entire boostback burn, then the entire entry burn, and then of course finally the landing burn.
I'm going to pull up this question that came in via Super Chat from Captain Q. I'm not sure what he's referring to, but he says, first stubby nozzles and now a stubby booster at SBL. Which is worse? And he says, go Falcon Heavy, hi from New Zealand. And I'm pulling this up, first of all, because I'm not sure what he's talking about, but also, Max, you were just in New Zealand.
Yes, I was. Not sure if this is a topic for now or a Flame Trunge episode of the future, but yes, myself and Jack and someone else named Brendan Gully were selected to photograph the 50th launch of Electron out of the Mahia Peninsula in New Zealand. So glad to see a fellow Kiwi out there watching along. We love you guys. It was an absolutely phenomenal trip. Jack and I thoroughly enjoyed ourselves and the company of Rocket Lab and, of course, the launch of Electron itself. Glad to have you on board.
So excellent stuff. And what is he referring to, Trevor, about the stubby booster? Are we not sure?
Yeah, so at Starbase, there is this booster B14.1, which is a test tank. And what they're doing with that is going to be a catch test. So what we're expecting them to do is load it with some water and then basically just kind of shake it around with the chopsticks to make sure that it doesn't damage the chopsticks or the booster itself. And that will hopefully somewhat simulate what a caught booster would act like in the chopsticks. So that's testing at Starbase that we were originally expecting to see this morning. And then today's road closure ended up getting canceled. And I believe there is now a road closure both tomorrow on the 26th and also Thursday on the 27th from 8 a.m. to 8 p.m. Local time where we're expecting this testing to happen. So it's just a really short, silly looking booster that is out on the orbital launch mount right now.
Very cool. That's gonna be quite a sight, I think, when they start doing, or I know when they do that for real, when they try to catch that rocket on the way down. Here's a question from KMS. I think I know the answer to this, but they didn't perform static fire tests on these new boosters, did they?
Yeah, so as usual, all of these boosters did undergo a static fire at McGregor. So they
Texas,
test every
actually.
single new booster and even new engine that they make at the McGregor test site. However, in Florida, there was not a static fire. So they have not done a full vehicle wet dress or static fire. It just rolled out yesterday for the first time. And then today will be the first time they light all three of the cores at once, assuming they get that far.
Interesting. And Max, what would they don't always do a static fire these days on the pad? Is that right?
Yeah, it's actually pretty rare nowadays to see a static fire, whether it be Falcon Heavy or Falcon 9. But I think prior to this Falcon Heavy flight, every single Falcon Heavy has performed a static fire, which is why it was kind of alarming to not see one. Yeah. Okay, Julie, just correcting me on the last one, or on that fact. The last Falcon Heavy as well did not static fire. But we still go into... I mean, I guess we almost expect a Falcon Heavy now to do some kind of static fire test when it's out in the pad, but that's just maybe creature of habit. And it's only flown 10 times, so the ratio is still there to static fire every single time. But that will change, I guess, as it goes on. Yeah, it's just very strange. And also, with 3 brand new cores as well, thought we would see additional testing on the pad, maybe a wet dress to make sure everything was safe and sound, but I guess that was not deemed necessary, and hopefully we have a clean count from now all the way through T0.
All right. Well, right now we are at about an hour and 5 minutes to T0 time. And a reminder that we are watching for the launch of Falcon Heavy and the GOES U satellite. U goes, and I'll have to start working on my puns a little bit when we bring Sawyer in. I got to keep up. So what will happen at the T0 mark is we will see a spectacular launch of Falcon Heavy if the weather cooperates. And we did have a super chat here from Alex Vives. Now, we haven't got confirmation of the weather from SpaceX beyond what we saw a little bit earlier, which is that right now they're working from a 30% chance of favorable weather for launch. But that hasn't stopped them before, and we will be watching to see if they fuel the rocket up. And Trevor, when we talk about the percentages here, it's really about predicting out from a day or two ago or maybe several hours before the launch. And as we get closer to the actual launch time, those numbers become a lot clearer because you're in that time frame now. You don't have to predict as far out.
Yeah, that's correct. So the latest weather we got officially from the 45th was at that L-1 day, so about 24 hours out. And then, of course, SpaceX updated us like half an hour or so ago with updated weather that was the same. So the 45th generally seems to be very good at their predictions, way better than your local or your phone weather app or whatnot. But yeah, that's all done by the 45th, and then they're ultimately the ones that decides if weather is good enough for launch or not.
We will keep an eye on things, and right now it looks pretty good to me. We got some blue skies there. It looks like I saw a photo from Max a little bit earlier. He's nice and sunny, getting cooked up there on the roof of the hut at the Kennedy Space Center. So we will just keep watching the countdown here and seeing what kind of activity that we see from here. And Max, this launch pad has a lot of history to it. Certainly, it was rebranded a little bit when SpaceX took it over, but a lot of the shuttle era components are still there.
Yeah, certainly. And 39A actually held a majority of the shuttle flights and also held a lot of the Saturn V flights as well, including the infamous Apollo 11 mission. But currently, all that is left from the space shuttle era and actually Apollo era is the fixed service structure, which is that black tower you see to the left of Falcon Heavy. And that has a bit of history and ancestry with both programs in the fact that that tower is constructed with the oh goodness, what are words right now? The sun is just baking my brain. The fixed service structure tower is made up of leftover segments. Well, I shouldn't say leftover. They were taken directly from the launch tower platforms that were used to launch the Saturn V and then put in place to accommodate and support shuttle. And the little structure, I don't know if you can see it on this feed. To the right, there is a little pivot, I guess you could say pivot point, and that is where the rotating service structure, or RSS, used to be, and that is where they used to integrate payload and shelter shuttle before launch. That of course, has since been removed, and SpaceX, since taking over the lease of 39A, has cladded the tower in black with white accenting, and of course has added the shiny white crew access arm, which is a few levels higher than what was there for shuttle. So yeah, it's still a bit of shuttle era laying around, but who knows how much longer that is going to last, and who knows what SpaceX has lined up for this pad and launch complex in the future.
That's right, because right now they're constructing the Starship tower to the right there, and you can see how much larger, we were just discussing a little while ago, how much larger that is versus the tower they have set up now. And presumably at some point, when Starship is the only system that they use, they will probably have to make some additional changes to the launch site there. Hey, I want to thank Amber for gifting 5 Red Team memberships to other members of the community, along with RC Horseman, who contributed 10 Red Team memberships. Thank you very much for your support. And we are just almost about an hour out here, 1 hour and 1 minute from the T0 mark of Falcon Heavy, which is launching the GOES U weather satellite, which will be a very important part of our lives, Trevor. This is one of those things that benefits all of us, doesn't it?
Yeah, I mean, I think a lot of people, when they're first watching what we do, wonder, like, why should I care? Why should we be spending money on this? And this is just one of those satellites that I think very clearly answers the question of, it lets us predict weather better. It lets us understand our planet better. It'll let us, follow climate models and all of that way better. And as Jack always says, more data, more better. And this is no exception. So this is an exciting mission for sure.
And it's funny because we got this question in from I'll put it up on screen here in a second. A random person said, maybe you talked about this already, but why did SpaceX report a low chance of acceptable weather today? And that's because you can only make these predictions based on the data you have. And if you have more data, you can make a finer prediction here. So as we near the T0 mark, there is a 30% chance of go, and it is a good chance if everything continues looking the way it does. That 30% will become 100%, and we will get this rocket off the pad. The next big milestone we are waiting on is the go for prop load, which will fix that T0 time in. And we expect to hear about that soon because, Trevor, this is going to be about 50 minutes before T0. Is that correct?
Yes, that is correct. And also, I quickly wanted to bring this up. We are now 40% or 60% go.
Oh, okay.
So weather has
That's a big
doubled.
change.
The goodness of the weather has doubled. So the primary concerns are still the same, but this is fresh off the press, if you will. So that's a good sign for the start of that they will go for the start of this window. And sorry, what question did you? Oh yeah, about fueling. Yes, so that will start here shortly. SpaceX's decision point for fueling is at 53 minutes for Falcon Heavy. And then propellant load begins at 50 minutes with RP1 load on the first stage, and then liquid oxygen loads begin 5 minutes later. And then the second stage fueling and filling timeline is pretty similar to Falcon 9, where they will begin RP1 load at T minus 35 minutes, and then liquid oxygen load at T minus 18.5 minutes. And you may be wondering, wait, Falcon Heavy or Falcon 9 starts our liquid oxygen load a bit later than that. And yes, that is because the T minus 20-minute vent on Falcon Heavy is not the T minus 20-minute vent. It is the T minus 22-minute vent. So that's just a little change in the second stage fueling timeline. But overall, as you can see, it is very similar for stage 2, and it is just stage 1 that is slightly
Launch
different.
control, this is the launch director on count to 1. Please pause the clock, and let's go ahead and push the T0 to 21:26:00 UTC. Copy, pausing clock and changing time.
21:26 UTC. So that is, what, a 10-minute delay?
Okay, I can live with that. It's better than
So
hour away, so that's or an hour further, so that's good. So a little 10-minute mark there, so we'll see that fueling begin a little bit later than we thought, but we'll reset our clock here too, a 10-minute slip. So we will continue to keep an eye on things, and we're going to have a shift change here. And I want to thank Max for helping us out here in the early part of the stream. I know you've got some work to do there in the hot sun, so we will thank you for your time today. Anything you want to add before we bid you adieu for launch time?
Honestly, you just enjoy.
We are counting down to 21:26:00 Zulu 20.
Sweet. Yeah, I mean, a 10-minute slip to the T0 into the window is not the end of the world. I mean, that's fairly minor by the broad scheme of things. But believe it is time to go catch some AC, get out of the sun for a little bit, drink some water, try and stay hydrated. But honestly, I think the best thing I can tell y'all and everyone else is just enjoy the launch. Falcon Heavy does not fly nearly as often as Falcon 9 does. And it is a treat every single time. So pleasure talking to y'all, and thank you everyone very much for coming along, and I will see y'all on the other side.
Right. Thank you very much, Max, and get cool out there. And I want to welcome in our friend Sawyer Rosenstein, who's got some good intel on the payload. I think you had some interviews with some of the folks behind this satellite. So let me ask you, Sawyer, how goes it? Oh.
All right, I've been listening. You've been doing pretty good with the puns so far. So I think the next pun token goes you. So
all right, I feel honored actually to get one from you.
Thank you. But yeah, no, I talked to two of the people, one with the NOAA team behind it and one with the Lockheed Martin team behind it who helped build the satellite. And I mean, this thing is about as high tech as it gets. You've got a coronagraph on this one to help, again, Earth weather and solar weather very tied together. So you've got that on there. You've got amazing technology that basically takes for what used to be a picture book slideshow to what one of them described as sort of like looking at a wave in a pool where it's that much smoother.
Wow. And how often do we replace this fleet of satellites?
Not very. Usually about 15, 20 years. Started with those are back in 2016, and these are still part of even though the GOES satellite. These are the GOES R network of satellites, which includes GOES U. Weirdly, I know it's not the most logical naming, but then again, when has anything in spaceflight naming actually made sense?
Right.
But once it
Except
is
us.
up there, it will be replacing GOES R, which became GOES 16, which became GOES East. So GOES U, which will become GOES 19, will then become GOES East, and GOES 16 will become a backup. And if you got that straight, then buy a lottery ticket because that's impressive.
Well, I'm impressed that you know all of this, and that's why we value your insights here on the NSF streams. And if you're just tuning in, we are awaiting the launch of the Falcon Heavy with the GOES U on the top of it, and it's going to go into a very high geostationary orbit to keep an eye on weather patterns down here on Earth. And we're about an hour and 4 minutes and 20 something seconds from the T0 mark, which was just pushed up about 10 minutes, but the weather is looking better. So visually, it looks better. And we went from a 30% favorable launch conditions now to 60% in the latest weather update. So that's good. Sawyer, are you outside right now?
I am outside right now. I'm very fortunate that where I am, there's a little bit of shade over here in the Cape
Okay.
Canaveral Space Force Station side.
Excellent. So where you are is actually the best place to witness the landings of these boosters, isn't it?
For the landings, yeah, we are approximately 1.8 miles away. I'm apologizing that I don't know the kilometer conversion off the top of my head. So we cannot see the launch pad from here, but we will be able to see the landings. So right now, the only thing I can show with my camera is the beautiful Cape Canaveral lighthouse that's here. But I promise we will try and get views of the landing if the internet here decides to cooperate. And regardless, we will record it, and I'm sure it'll end up on our social channels. So make sure you follow those.
Awesome. We've got a lot of people out in the field today. I know Sawyer's out there, Max is out there, Dee is out there, and I think Julia's out there as well. So we'll be hearing from everyone's favorites in the course of the coverage today of not quite a rare event, but not a usual one, which is a launch of a Falcon Heavy. I've got a super chat here. Maybe I'll toss this to Trevor and Sawyer can fill in too. Josh King is wondering, is there a reason why SpaceX removed some of the cladding on the tower earlier this year? The tower does go through a lot of changes over time.
Yeah, that's a good question. So, the cladding that they're referring to was basically only for looks on the tower, and it did look very good, but it just got destroyed by Falcon Heavy and increased pad turnaround time. And as SpaceX has been using these pads as to the extent that they are, right? They're hoping to launch 150 or so times this year. They just want to remove as much work as possible during the refurbishment process. So part of that was just getting rid of the cladding.
So really just the fact that these rockets are taking a toll on that tower. And if you don't need it, get rid of it. So that's how it
Yeah,
goes.
Falcon Heavy definitely does a bit of damage to the pad and TE and everything. It's certainly substantially more refurbishment that they need to do to it than after a Falcon 9 launch, which I think is for two reasons. First of all, there have been like obviously Falcon Heavy is like 3 times more powerful than Falcon 9, so you would expect there to be a little bit more damage. But then more than that, they've launched Falcon 9 300 and some odd times at this point, so they have a very good idea of what on the TE is going to get damaged and what they need to replace and whatnot. Whereas with Falcon Heavy, this is only the 10th launch, so they don't have as good of an idea of that yet.
So we will keep an eye on that. And one of the things, Sawyer, that always surprises me is all the things you don't think about. And so much of spaceflight kind of depends on different types of trades that you wouldn't expect, like civil engineering, if you will, for these launch pads. The concrete has to get resurfaced quite frequently, especially in those flame trenches.
Yeah, I mean they're definitely more reinforced than say your average concrete driveway or something. But yeah, they do take quite a beating and quite a heating. So they will over time go in and repair some of those flame trenches over time, especially when you have 27 engines blasting into it. So that's part of also the turnaround cadence that you kind of see at 39A. It does take a bit of a beating. They've gotten that a little bit nicer now down at pad 40.
And it also goes to show you, too, that the cost of space flight is not just the rocket and the fuel and the payload. It's all the other stuff that supports that flight. And you certainly don't want pieces of concrete flying all over the place like, like we saw during that first Starship launch. So if you're just joining us, we are awaiting the launch of Falcon Heavy with the GOES-U weather satellite on board. We are just about an hour now from the T0 mark that SpaceX just sent. We have a 2-hour window, which we are now 10 minutes into based on the count. But I believe, Trevor, we should be getting word on the go for prop load in about 7 or 8 minutes.
Yep, that T-minus 53-minute mark, assuming that this T0 of 212600 UTC holds.
And Sawyer, this is a brand new shiny rocket. All the parts.
Yeah, I mean, you've got a couple boosters making their first flights here. The core stage will be making its one and only flight, as that is not recovered. But hopefully, again, just a short distance away from where I am, we'll have 2 side cores that land at LZ1 and LZ2. Also of note in terms of recovering the center core and things like that, if you were to manage to reuse a center core, it could not really be easily converted to a Falcon 9, whereas the Falcon Heavy side cores, if needed, can be converted to a Falcon 9 single stick.
That center core has to be massively reinforced, doesn't it?
Yeah.
Oh, absolutely. Oh, you want to take this one, Trevor?
No, go for it.
Basically, you've got the force of the 27 engines, including 18 on the sides, 9 on each side, pushing on it. You've got the mass of the satellite on board. The center core even throttles down to about 40% once it's in flight for a little bit to kind of ease the loads on it. So, yeah, it takes quite a structural load, and thankfully does well.
Sure does, and we've seen this system work quite successfully a number of times here. So that is exciting stuff. And we have a super chat here from Aramil, who says, "Goes where, goes you, goes them, goes who, goes to, right?" And it's going to go up, hopefully, in the next couple of minutes here. We're just awaiting word on whether or not SpaceX will begin prop loading. And when they do prop load, which is the fuel for our rocket today, that will lock our T0 in. But we do have improving weather conditions, much better than we thought at the outset here. So I am optimistic. I don't know about you, Trevor. How you feeling? I'm always feeling like, you know what, SpaceX can find those opportunities to punch through the weather.
Yeah, they're generally pretty good at this. And 60% weather for SpaceX, I feel, is generally closer to like 80%. They always feel a little pessimistic.
Current new T0 will be 2126 Zulu. And based on the LO's report, we're looking at roughly about a 30% POV during that time to help us avoid a storm cell. That being said, I'd like to go ahead and conduct the propellant load and launch readiness poll for the NASA engineering team. NASA CE.
NASA CE, go.
SMA.
SMA, go.
SMD.
SMD is go for propellant load.
And we
NASA
did hear
MIM.
there that space
NASA MIM is go for propellant load.
LSP.
weather has improved more.
The NASA
Yes.
engineering team is ready for propellant load and launch.
Right.
Yeah, so if you guys may have missed that during that call, they are still on track for the 2126 UTC launch time in 56 minutes. And weather is now 70% go. So it's improved from 30 to 60 to 70. So very good news.
I think that's Sawyer should take credit for that. Once you got out there, the weather started improving. So you are a bright light for Rocket Sawyer. So we'll keep that weather behaving itself.
I've been called a ray of sunshine before, so that's probably why. I mean, I've been called some other things that I can't say on the air, but that's another story.
That's right. We like to focus on the positive, and we are going to give you all the credit for the weather right now, along with Max and the rest of the team that are out there in that sun, which is thankfully out and not behind clouds. Hey, we got a nice super chat here from, hope I get your name right here, Elisers, who contributed $100 to the effort today. We greatly appreciate everything that you all are contributing today, including this very generous super chat, which helps keep everything going. We've got people and infrastructure all over the place. We have cameras focused in on all of these activities 24/7, and your support is what makes that happen. So thank you all for those generous contributions, including that nice super chat. And also pull up JS Web Productions here, who gifted a Red Team membership to one of our viewers there. So thank you very much for that. So here's a question. I'll toss this one to Sawyer first. You know, we don't think of, we know Falcon 9 is human rated. You can put people inside a Dragon and go up on a Falcon 9. But what about Falcon Heavy? Certainly we don't need it to put people on it. But if needed, could we use Falcon Heavy? Or is it just a little too much thrust?
Nope, even if needed, you couldn't. There was originally plans potentially for it for Grey Dragon and Red Dragon, which were going to be the Lunar and Mars variants of a Crew Dragon. Obviously, that is now known as Starship and looks very different from the original renderings back when it was going to fly on Falcon Heavy. But no, since it is such a different vehicle from Falcon 9, it doesn't carry over the crew rating, and there is no need to.
And I just want to clarify, I see a little bit of confusion in chat.
And
that go, no-go poll we just heard was for NASA.
Proceed with propellant loading.
The NASA team is ready to proceed with propellant load.
Copy, thank you.
This is not SpaceX's team. SpaceX will have their own internal go, no-go poll, which will begin here in just about a minute. And that is done electronically, so we will not hear the go.
Polling is
like
complete, and we're go
did
for
NASA.
propellant loading and launch.
And that actually may have been that confirmation.
So now, if we are indeed go for propellant launch, and again, we believe we just heard the NASA confirmation, not the SpaceX one, but that sounded pretty affirmative. So once we begin that prop load, that T0 is locked in. And Trevor, we have a 2-hour window here, but they could not reset after prop load. Is that what I was hearing?
Yeah, that's correct. So that last go was actually, that was the SpaceX go. So NASA had their go first, and SpaceX just concluded their go, no go poll. So they are go for propellant load here in 3 minutes and 20 seconds. And once they begin that propellant loading, they are locked into the 2126 UTC T0, which is 5:26 local time. So good news for everyone out there. Good news for a launch today. And again, weather has improved all the way from 30% go originally to 70% go now.
And that is why you always have to remain optimistic, right? If you can make it work, you make it work, because it costs everybody a lot more money to keep this thing on the ground. Sawyer, you've been to a number of launches and have observed just about every one that you haven't been to. How often do we start with a bad weather prediction and end up going? It's pretty regularly, right?
Way more often. Way more often than you think, and way more often than I'd like. But indeed, I have seen launches where they are 40% and they go. I've seen launches where they're 90% and they don't go. That's the joy of spaceflight, and I keep always getting told, why don't I pick a profession or a career that actually is set? Like when they tell the time, it's actually the time. But that's the fun of it in a way. So for now, though, I will take that we are 70% goes.
I have to, there you go, good one. And I have to say, you know, in the early days of SpaceX, there was a joke around the press corps that they could never hit the T0, and now they generally,
Falcon Heavy tanks
more often than
preventing
not.
for the starboard propellant load.
That's what we want to
This is
hear.
the launch director with abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operator shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
I just want to emphasize, by the way, those are instructions. That is not a hold. That is just SpaceX informing all of the launch operators what to do if they need to hold the launch. But for now, we are still good for propellant load, which will begin here in a minute.
And as we're waiting here, Jonathan Tucker wants to know, when is the NSF's go, no-go poll? But we are always go, especially today when we're gozing. I'm not as good at this as you are, Sawyer, so I'm sorry.
It takes time.
Does. I'm working on it. We have another super chat here from German pilot. Do you guys remember the Boeing 747s that NASA used? We sure do. And they used to haul the shuttles around on top of them. That was always something to see, especially those last flights they did as the shuttles were bringing those space shuttles to their final museum locations. Always good stuff. And of course, another thing we always have to do here is have a go for our shuttle reference. So I don't know if Chris B's watching today, but that's for you.
Mhm.
And
The shuttle carrier aircraft known as NASA 905 and 911 that were previously American Airlines planes. In fact, for a while they still flew with the red, white, and blue stripes on the metallic side before they eventually repainted them. As mentioned, they are now in museums, and you can learn all about Shuttle on Shuttle Sundays every Sunday at 3 on Space Coast Live. And if you miss it, don't worry, we have
The
the
launch auto
playlist.
sequence has started.
Subtle plug, huh?
Great stuff. And I hear an auto sequence start there, so that's a good sign that we're progressing through the count, Trevor.
Yep, so that means they're into propellant load. The first sign that we will maybe see is frost. However, the fact that it's a brand new booster will make it somewhat difficult to see when we start seeing frost, since we don't have the nice soot marks that get covered.
That's right, but it's so humid, I'm sure we will see a lot of that condensation coming out there. So we don't see these shiny new rockets like this too often anymore. I don't know if you heard me there, but yeah, it's almost like nostalgic. It looks like the first one that was just brand spanking new out of the out of the factory. Everything is bright white here. We don't have even the second stage there is all white, where nowadays they're black on the Falcon 9 missions. But yeah, there's no soot. But I think when those boosters come back, Trevor, those boosters are going to be pretty sooty when they land.
Yeah, that's for sure. And I've seen a few people wondering, I don't think we have explained it yet. There's that gray stripe on the second stage above the
Yeah,
inner
what is that?
stage. Yeah, so that is not the inner stage. That is what's called as the mission extension package. So on today's mission, SpaceX will be conducting 3 second stage burns. The third of which ends at T plus 4 hours, 21 minutes, and 51 seconds. So it's a very long mission today. And in order for them to be on orbit for that long, they have to have a few changes to the second stage. So the first is they add a bunch of COPVs so that they have more ullage gas for pressurization and also for attitude control during these very long coast phases. Since not only are you in such a long coast phase, but you're also having 3 burns, so you need more more gas for propellant settling. But then also you have to worry about temperatures. And what the gray stripe does is, since it's just a bit darker than the white rocket, it absorbs more heat, which helps make sure that the RP1 doesn't freeze. So that stripe is just on the RP1 tank of the second stage and is there to make sure that they're able to do this quite extended coast phase, which again, payload deployment isn't until T plus 4 hours and 30 minutes. So it's a long mission today, but that is not the inner stage. The inner stage on Falcon Heavy is white.
It's pretty neat when you think about it. That's kind of a passive solution to the problem. I see a little puff there of some venting, which is encouraging that there is some fuel going in at this point. But it's a passive kind of approach to temperature management. Let's make it a little darker.
Yeah, especially on missions where they know exactly when the payload's going to be in the sun versus in the shade. As obviously it doesn't do much if you're not having photons hit it and being absorbed, but when you are in sunlight, it is a great solution.
And we're starting to see some puffing going on there. I don't know if Sawyer, we lost you for a minute there. I'm not sure if you're still with us, but what are we looking at here if you're still with us?
Oh, I'm still here. I'm looking at clouds on my camera, which there aren't that many because I can't see the pad from my current view. I don't know if it's clear enough to even show on camera, but yeah, right now I'm near the landing zone. But what you're seeing there, again, here's a look at the sky live at this moment as we pan right over where LZ1 and 2 are located. So,
all right, you're gonna get a great view.
I think that's pretty darn clear. So,
yeah, you should see them coming in.
But otherwise, that's the hope. But you'll see a little bit of puffing. So, that puffing is fine. That's the fuel getting ready to load in, things like that. So it's gorgeous right now. So hopefully the fueling goes well and we're ready to go.
All right, well, we're about a minute to LOX load on the first stages, so we will be keeping an eye on things as developments develop here. But we are, if you're just joining us, about 45 minutes and 30 seconds or so away from the T0 mark of this Falcon Heavy launch, which is launching GOES-U, which is a NOAA weather satellite, and this is being done in partnership with NASA. So we've got two agencies and their commercial supplier, SpaceX, who will be delivering this satellite up to geostationary orbit today. And when we started the stream, our weather forecast was 30% favorable. Now, I think we're at 70% favorable for the T0 mark. We haven't heard a recent update on the weather, but it was looking good. So
Stage
we
1,
may
BY,
get this.
NY, LOX load has started.
And there you go, right on schedule. So LOX load is beginning on the first stages there. So we are moving along here, Sawyer. I'm feeling good. And we will continue to watch the count here as we're awaiting things. Now, Sawyer, you're going to be watching these two side boosters come back down in a little bit. I think we lost Sawyer again, but I'll keep going. So where Sawyer is located is out on the Cape Canaveral Air Station there, and that is where the two landing zones are for the first stage boosters of this Falcon Heavy rocket. So as it is going into orbit, that center stage we're not going to see again after liftoff. It will be expended due to the weight of the satellite, where it's going to be placed in orbit, and how much fuel is required to get it there. So the center core will basically splash down in the ocean and explode. But the other two stages, the two side boosters, we will see coming back in. And where Sawyer is located, he's less than 2 miles away from the landing zone. So we should get a pretty good view of that in a little bit. And Trevor, one of the things that I love.
Are you able to hear me now, by the way?
Oh, yes, we can hear you now. So we're just talking about you're in a good spot to see those boosters come down. What do you expect to see?
From what I've been told, at this location at Cape Canaveral Space Force Station, it's a little bit farther away from the launch, but this is one where we'll go almost directly overhead in theory. That's the hope, at least. I mean, the skies are absolutely gorgeous. Right now, probably the best view that we have of anything would be the lighthouse near Cape Canaveral Space Force Station, which is kind of close to the landing zones, but it is gorgeous out.
Right. Well, we will keep an eye on the weather, and if those the skies look the same as they do now, then as they will hopefully in 50 minutes or so when those boosters come back, you should get a good show today as those are coming in. Hey, I've got a couple of super chats here to acknowledge while we're watching the countdown here. Lalo Ruval Kaba, hope I got that right, with a $10 super chat, says, I love the NSF streams. So Lalo works in cold storage for stone fruit in California. So when it's 105 degrees outside, it's a nice 34 degrees inside. That's something you would probably like to have right now, Sawyer. They have to wear a cold weather suit to go to work because they're working in such cold conditions. So that is some super AC. And Sawyer, what's the temperature out there right now?
That's according to my phone, it is 88 degrees Fahrenheit. Again, apologies that I'm terrible at conversions. I'm American. Cut me some slack.
I'm in the same boat. I'll do the math for you. So that is 31.11 degrees Celsius. But you also have the humidity, which makes it feel hotter and stickier. So we.
Oh yeah.
So it is definitely there. And Trevor, as we're watching the count here, we don't see a lot of condensation yet, but that's because this is such a new rocket.
Yeah, so that's certainly part of it, is that it's hard to see frost because these boosters are, again, all brand new. So frost is obviously white, kind of hard to see white. That said, we're hoping that we'll be able to see it a little bit, but I certainly don't see any signs of it quite yet.
We'll keep an eye on things, but we know they see a little bit of venting there on the service structure, so I know that they are fueling.
Alex says he can see it.
Okay. So, yeah, I see a little bit going on.
You can definitely see a little bit of condensation coming off of it. So that's a good sign for sure.
Yep, it sure is.
Also, I love how I could hear you leaning into your monitor to see that, Trevor. That was
we are not on cams today, but you can definitely hear it for sure. And I'm in PG here has a question about the app with a $4.99 super chat. Would you consider adding a tracker in the next spaceflight app to keep track of launches you have witnessed in person or seen virtually? So I can definitely pass that along to the developers as we put it up on screen here. You know what I do to track the launches that I've seen, guys? I buy a mission patch for every launch that I have seen. So I've been to 7 of them now, and I've got them all right above my desk here. So that's a great way to keep track of the launches, I think, to be able to have those patches up on the wall. So kind of fun
I'd
way
be
to...
broke.
You would be. Yeah, sometimes they offer like the bulk pack where you can get like the last 10 missions or something. So they are not cheap. The good ones are costly. We have some great ones, by the way, at the NASA Spaceflight store. So be sure to check out what we've got in the store for you, because if you need some patches, we got them for some of these missions. Flawed Perspective has a super chat for just a 3 laws of robotics software update for Sawyer. Must be an inside joke.
I guess.
And,
I missed
yeah.
what was that? I'm sorry, one more time?
It was a 3 laws of robotics super chat for you update. I'm not sure. So that was what they put on.
I know
there,
I'm missing an obvious reference here, and I'm sorry. It's hot.
Yes, it is hot. We'll have to ask for clarification of that. Now, if you're just tuning in, what we are waiting on right now is the launch of Falcon Heavy, a brand new Falcon Heavy with 2 new boosters and a shiny new center core. And this is a launch for a weather satellite for the U.S. government, for NOAA, and for their partner NASA. And we will see those 2 side boosters come back down to land, not far from where our Sawyer Rosenstein is currently situated. So we should have some good views of the return trip along with the launch, now less than 40 minutes away. So we are making good progress here. The weather has been looking good. So we are so far pretty optimistic here that this will go with the goes in a little while. So Trevor, what are the SpaceX folks doing now? Just waiting for the fuel tanks to fill up, or are there other things that go on in this part of the count?
Yeah, so we're coming up, right? We heard that call out that PY and MY liquid oxygen load had begun, and we're coming up at T-minus 35 minutes of second stage RP1 load beginning. But I've seen a few people wondering, right, we keep talking about this PY, this MY, SpaceX is saying it. What on earth does this mean? And it's not quite as cool as you would think. It just stands for plus, PY is plus Y and MY is minus Y. So that's referring to the axis of the booster, of the vehicle. So you can see in this diagram from SpaceX's launch user's guide, it defines the coordinate system that the vehicle is designed around. So the x-axis is going all the way through the vehicle, like through that center E9 engine into the fairing half. And then we have the z-axis, which is going up and down on this page. And then to the left and right is the y-axis. And one of those boosters is on the PY, the positive side, and the other is on the minus Y side. So that this PY and MY is just what the names they give to them so they can distinguish, are we talking about the booster on the positive side or the minus side? And this, you also hear right in the callouts where at this point they're basically doing the same thing, but later on in the mission you'll hear like PY, MY, FTS has been safed and other callouts like that, and then sometimes you'll hear like maybe just one of them has started its entry burn or whatnot. So it's just a way to distinguish these 2 cores.
Sawyer, in looking at the core configuration of Falcon Heavy, you have potential here. If one of the boosters should fail or not perform appropriately, you could have some pretty difficult issues in getting your rocket to orbit. That's very different than Starship, where everything is kind of center located.
Yeah, Falcon Heavy and Starship are quite different there. So even though it's only a difference of 6 engines, the fact that you have them spread out is different. I mean, you still get some of the same type of things that you're used to seeing with Starship on Falcon Heavy, in that while Starship has rings, this just has the separate boosters. You've got some differential thrust in parts, so they're kind of similar. But of course, one is a giant stainless steel thing that somehow, with a burning flap, survived, and the other is a beautiful 3-cord rocket that's about to carry a NOAA NASA weather satellite to space. But I love
one
both.
of the things we sure do.
This
We
is
love every
one-
rocket here.
This is one thing, though, that SpaceX intentionally did with Starship, is they wanted to minimize the number of state changes. And right, this is one area where Falcon Heavy is in some ways bad, if you will, because there are just so many state changes that the vehicle must go through. You have the side cores that are that have to fall away from the vehicle. Then you have separation of the center core from the second stage, and then you have fairing deployment. With Starship, there's just one. It's just stage separation, and then later, you keep the fairings on, and there's confirmation that prop load is started on second stage RP1. But the fewer the state changes, the fewer things can go wrong, and that's was one of the design philosophies of Starship, and also one of the many reasons why we're never going to see SpaceX do a tri-core vehicle again. So we need to appreciate these Falcon Heavy launches while we can.
It is a rare bird and will become rarer as time goes on. And one of the things that I also was fascinated about with Starship, Sawyer, is that Starship doesn't need to be held down because it's so heavy, and once it has enough thrust, it just goes. Again, pardon the pun. But in this case, with Falcon Heavy, they do hold it down to make sure all the engines are firing off first, don't they?
Yes, they do. Whereas Starship needs, once it gets to a thrust weight ratio above 1, it goes. This one, they slowly ramp up the engines, but they are hopefully all firing at 100% by the time that it actually takes off from the pad. So there's a slight difference in that, but the end result, we hope, will be the same in that it launches successfully.
And we are now within 34 minutes of the launch of Falcon Heavy. The weather has improved if you're just tuning in. So NASA and SpaceX have gone ahead with prop loading, and you can see some of the venting and condensation forming around our beloved Falcon Heavy here. And we are just waiting the countdown here to the T0 mark. There was a 2-hour window for today, but because they have now gone for prop load, that kind of locks your T0 time in. And Sawyer, I have an update as to the 3 laws of robotics reference from earlier. It's because you are having some bandwidth issues out there, so you were sounding a little robotic. So they thought perhaps this was the AI Sawyer joining us today and not the real one. But I think I can vouch for your realness.
I'm sorry, what?
So you were sounding a little robotic earlier. So that was the 3 laws of robotics that they were referring to. Yeah.
Oh, and yes, Strawberry has 2 R's.
So this is not the AI
It's a
Sawyer,
post about AI. Yeah.
And we have some super chatters here to thank. Interstellar Gateway with a $19.99 super chat. It is Falcon Heavy Day. It sure is. Here's a question from I'd rather be flying an X-Wing. I would rather be flying an X-Wing too, as a matter of fact. Think about how much easier it would be to get to orbit with an X-Wing. If there was a heavy enough payload and Starship wasn't ready yet, could Falcon 9 ever use solid rocket boosters? Who wants to take that one? Because that's certainly out of the design scope of these, isn't it? Let me talk to Trevor.
That's something SpaceX just will not do. It goes against their entire philosophy of rapid reuse. Solids are not reusable, let alone rapidly reusable. So
that's it. It just defies it. It's kind of like putting LiDAR on a Tesla. It's just not going to happen. So they will rather work to get Starship working in its full configuration here. So we are about a half hour away now from the launch of the GOES-U weather satellite on board a shiny new Falcon Heavy. And Sawyer, when these boosters come back, they're not going to look so clean and crisp anymore. And it's not the re-entry that does it. It's something else.
Well, a major portion of it has to do with basically as it's coming back in. One of the things it does to help slow itself down as part of the entry burn is we like to say it fights fire with fire, where it essentially creates sort of like a thermal blanket around it using its engines. And as a result of a bunch of different processes, which I've been told I explained too simply, so I don't want to get too complicated, I'll just say following that, you see a lot more soot.
And that's because the fuel they use is kerosene. So
it's a long chain hydrocarbon base, yes.
Got it. And so when we look at future rocket launches that are happening now, not only with SpaceX, but many other launchers around the world. They're shifting to methane. So would we see presumably a cleaner rocket after that fuel shift begins?
I'm sorry, I missed that part. You cut out for a second.
I say as some of these launchers are switching to methane as their fuel, which burns a lot cleaner, you probably won't see as much soot in the future. Now, of course, Falcon will never use methane, or it could.
Yeah, I mean, not as much. I believe methane still is carbon-based, if I recall correctly. If I'm wrong, someone will, I'm sure, yell at me in the back channel. So
there's a single carbon.
So
single carbon. So you will get some soot.
So yeah, it's not anywhere near, but yeah.
All right, so we are awaiting the launch of the Falcon Heavy. We're about 30 minutes away at this point, and all is seeming to be going according to plan here. We don't have access to the SpaceX comms, but we haven't heard any news to the contrary here. Fueling is going. It looks like we're at about, at least as of 7 or 8 minutes ago, at 50% RP1, and LOX was at 30%, but it fills up pretty quick. So we are getting close to the T-22 vent, which is the big vent that we typically see on a regular Falcon launch. So we will be on the lookout for that. And given the humidity today, I think we'll get a good vent when that happens. So, but no chatter we're hearing. We do have SpaceX comms, actually, and we're not hearing any chatter. So that's a good thing. Things are counting down on schedule here. So Trevor, what do you think is happening in SpaceX at Mission Control right now? What are they looking at?
Yeah, I mean, at this point, it's almost entirely automated. So the operators should just be looking at data, looking at weather, looking at the range, making sure that they don't see anything that they don't like. But in terms of what they're doing, it really shouldn't be, a whole lot if everything is going well. SpaceX, just like they will never use a solid rocket motor, they also want to automate as much as humanly possible. Since computers, when you're launching this many times, it's better to have as much work done by a computer so you don't wear out your team. So probably not a whole ton, but who knows? I'm sure there's some issues that are coming up that they're wanting to double check, check, is the sensor maybe bad? Is this piece of data slightly out of line? Just all of those sorts of things.
Sawyer, there's when we look at the SpaceX launches, as Trevor just mentioned, it's all very much automated, and that includes even some of the abort procedures too.
That is absolutely true. What a lot of do now, as opposed to someone sitting there with a big red button or two keys that have to be turned, things like that. A lot of it now is what's known as the autonomous flight termination system. I'm not sure if it's autonomous or autogenous, but essentially meaning that once it gets above a certain parameter, the onboard systems automatically activate the flight termination system as is. A lot of them just recently got clearance to be used here at Cape Canaveral.
That includes even some of the detanking procedures too. So it's very much an automated system. And Trevor, the other day we saw a Falcon Heavy Falcon 9 launch light its engines and not launch right before it was released to go to orbit. So these computers are keeping an eye on things right down to T0.
Yeah, and not just through T0, but also through the entire launch. Sawyer was saying SpaceX uses what's known as autonomous flight termination system. So if something was to happen to the vehicle, if it goes off course, then it realizes that and detonates itself. So that's been a pretty huge advancement in rocketry, since not only is it safer, but also just reduces more stress off of humans, which is a very good thing.
Right, because if a human has some doubt as to whether or not to actually push that button, that's taken out of that decision tree, and you hope that all of your other mechanisms, especially if on a crewed flight, can bring the crew to safety. So it certainly probably ends up being more safe than it would be if there was a human at the controls. So we are almost up on our big vent. We have been seeing some vents coming out of Falcon Heavy on the pad as we await the launch of the GOES-U weather satellite. I know a lot of people tend to tune into us as we get a little closer to launch. So maybe I'll turn it over to Sawyer again to talk about the payload today, because you got some interviews with some of the folks behind this new satellite. What's it all about?
Satellite is going to be part of the GOES-R set of satellites. There are 4 launched that originally launched as GO-R, S, T, and in the case, you surprisingly going actually alphabetical, which were named GOES 16, 17, and 18, and this will become GOES 19 in orbit. That will complete their network of GOES East and GOES West, which covers almost about half the globe, although primarily we see it a lot in the United States and Canada and North and South America. It actually looks at the Atlantic and the Pacific as well to keep an eye out for storms, send super important weather warnings. These newer ones are much improved in that they, instead of sending data every 30 minutes, can give updates every 30 seconds, which is crucial in these life-saving matters. In addition to that, it also has lightning trackers that can track up to that take up to 500 snapshots per second to track lightning in real time. It also has a signature on board that can read distress signals from ships. And so far this year, it has already saved 150 people by listening to those distress beacons and relaying them to local authorities. So these are really life-saving satellites. And that's in addition to the solar observatory things that are on there that also look at solar.
The solar weather also, absolutely. So it's pretty amazing. And when you think about some of the things that can benefit everyone, even today, where we were at a 30% favorable weather forecast leading up to this launch, now we're at 70% favorable conditions, at least of the last weather update. And it just goes to show you, if you have more data that you can take more frequently, there you go. Trevor, one interesting thing about what Sawyer just mentioned about the marine safety issues and the distress signals. They have these little devices that basically activate when they start floating in the water. And I live in a community where there's a bunch of boats and marinas nearby, and every once in a while somebody opens one up by accident, and they respond quick. It's pretty amazing how effective those things are. So, so we will be keeping an eye on things. Sawyer is out in the field. He's actually in a great spot where he's going to see those boosters come back down. We're having some bandwidth issues there, so we will keep working on that, so he sounds less robotic. But Sawyer is definitely the real Sawyer. We have not outsourced yet to the artificial intelligence yet, but the real Sawyer is quite intelligent and provides great information for all of us here, and we'll be working on improving his bandwidth situation. So here we are at 23 minutes, Trevor. What's the next big milestone we should be looking for?
Yeah, so we're coming up on that T-minus 22-minute vent. This is the vent that on every Falcon 9 launch we say is the best vent, except for it is 2 minutes earlier with Falcon Heavy. And this is just because, as I was mentioning earlier, the propellant load sequence, while very similar on the second stage, is slightly different. And that's so they start liquid oxygen load just a little bit sooner on these missions. So this line, so at T-minus 22 minutes, we'll see large venting come from the transporter erector, which you can see right there in front of the center core. And what this does is chills down and cleans the line. There it is, that T-minus 22-minute vent. This chills the line down ahead of liquid oxygen load. So up to this point, SpaceX has only been loading RP-1 onto the vehicle, which is basically ambient temperature, a little under ambient. But liquid oxygen is, about negative 210 degrees centigrade or so. So in order for that to not get instantly vaporized from a liquid into a gas, they start chilling the lines down ahead of time. And the vapor from that is what you're seeing vented now, which is going through the tower, which is pretty awesome to watch.
Yeah. Quite a vent there too. So you've got a lot more fuel going through this this particular spacecraft, given it's basically 3 Falcon 9s strapped together. And a question here from Private in the chat. This center core doesn't have any grid fins on it, does it, Trevor?
It does not. And it does not have landing legs or grid fins or any reuse hardware, because this center core will be being expended on today's mission. So they need all the performance they can get out of that center core. So in order to get that performance, they have to expend it. However, the side boosters will be performing an RTLS landing. So they will be doing their boostback burn and coming back all the way to the Cape. but unfortunately that center core, this will be its first and only flight.
So hopefully it'll be a good and spectacular one, which we'll hope to see in about 20 minutes here, because it looks like the weather has improved tremendously from where we thought it was going to be today. So that is a good thing. Todd Bronco here is a question that I actually... All right, looks like we have a good milestone there, Trevor.
Yep, so that was fuel load being complete on stage 2, just as we expected. So, all right, fuel load is complete, and they just have liquid oxygen load left on stage 2, which we expect to begin at T-minus 18.5 minutes. So coming up here in about a minute and a half.
All right, and as we await that next milestone here, there was a question from Todd Bronco about the VAB squeals, and I've experienced those myself, which is so cool. So what those are is the sound of launches and sonic booms bouncing off the side of the vehicle assembly building, which of course is metal, and you hear these metallic echoes as launches occur, depending on conditions, along with the sonic booms of spacecraft returning. And I was there in 2019 for the launch of Falcon Heavy for Arabsat. And when those boosters came down, we had some really nice, loud sonic booms, 4 of them, because you get one off the top and the bottom of the booster as they come back down. And that followed by a twangy echo that was bouncing off the VAB. And I actually have a video of it. It sounds so cool. So that is what those VAB squeals are. And the VAB does squeal when you have some of these launches going on and you're down there at the press site where you're right next to it. So good stuff. Chad Griffith here with a super chat at Jetty Park, awaiting a spectacular launch. Thanks for the great coverage. Thank you for tuning in. And we are excited for Falcon Heavy launches. They are not as common as Falcon 9, and they are certainly a lot more spectacular, given you've got 3 of these rockets strapped together. It's always fun to watch one of these lift off the pad. Spruce McKay in the chat room is watching from Jetty Park Beach. He's been watching NSF for 7 years now, and drove down from Boston for this, a fellow New Englander here. Fingers crossed that we can launch today, because he's got to drive back to work tonight. I know the feeling, and that's a long drive to go all the way back up. But it's worth...
Stage 2 load has started.
Right, there we go. Stage 2 LOX load has begun.
Right on schedule.
Right on schedule. That's one thing you can say. They're very punctual at SpaceX. But yeah, it's if you have a chance to watch one of these go up, definitely Falcon Heavy is something to see. And again, doesn't launch as frequently as Falcon 9, only when the payload requires it there. So there we are. You can see some of the upcoming milestones here. And we'll begin engine chill next at, I believe, T-minus 7 minutes. So we are working our way through the countdown timeline. And so far, weather looks good for the launch here. So we'll just keep our eyes on pad 39A at the Kennedy Space Center. So right now we are in the stage 2 liquid oxygen load. And Trevor, why does SpaceX fuel up so close to launch?
Yeah, so SpaceX does something that certainly they're the only modern rockets to do this, but I believe there may have been some old Soviet rockets that did something similar. So they super chill their propellants, and what that is getting them to be as cold as possible. So whereas most rockets, their liquid oxygen is just a little bit below, is stored at just a little bit below its boiling point. What SpaceX decides to do is store it just above its freezing point instead. And what this allows them to do is, as you chill it down more, it gets denser. And when the propellant gets more dense, that means not only can you store more propellant on the vehicle in the same volume, but it also means that your engines are suddenly higher performance since you have more mass flowing through them and whatnot. So it's kind of doubly advantageous for them to have this super chilled propellant. However, as you can imagine, if you're storing it at just above its freezing point, it can warm up from that freezing point to that boiling point and start expanding. And what SpaceX doesn't want to have happen is load the vehicle, hours ahead of time like ULA does, because then you would have this expansion and have a bunch of boil off. and the propellant wouldn't be as cold. So they load so late, especially the liquid oxygen, right? Liquid oxygen load wraps up in the final few minutes before launch. They do that so that the propellant is as cold as possible for launch. And this is the thing, right? Earlier you were talking about how back in the day, SpaceX scrubbed or had to delay almost every mission. That's because they were figuring this out. This is a very hard thing to do. We saw SpaceX, had some challenges with it, not only with all of the scrubs, but also with AMO 6. But these days, they have figured it out, and it allows them to have higher performant vehicles. So loading late is just advantageous.
And I hear from the SpaceX net that things are looking good weather-wise. So they are still on track here as we approach the T-minus 15-minute mark to the launch of Falcon Heavy with the GOES-U weather satellite. And unlike a lot of the communication satellites we often see get launched on these rockets, this one is one that we're all going to be using to know what the weather is like, how to predict what's coming up. It has the ability to deliver much more data more quickly. So it can provide a real improvement to weather forecasting along with a number of other things. And I also found interesting that it's not only looking at weather on the Earth, but it's also measuring space weather. It's looking at lightning. It's got a lot of capabilities that we don't have in orbit now. So this will be a significant addition to NOAA's satellites in orbit. So this will, I think, get a lot of our meteorologist friends out there very excited because they will have a lot more data to work with, hopefully, in the next couple of minutes here after, of course, satellite gets to orbit. Now, Trevor, this mission, as far as its delivery to orbit, is going to take a while. So we're not going to be on for the full 4 hours it's going to take for the satellite to reach its destination, but that's how long it's going to take, isn't it?
Yeah, so today's mission, right, it has 3 second stage burns. So the first is, of course, the one that will start just after stage separation, which stage separation is basically 4 minutes into flight with SES-1 starting at T plus 4 minutes and 6 seconds, which, by the way, you can notice that this is about 30 seconds later than in a Falcon 9 mission, and that's where all of the extra power of Falcon Heavy goes into those 30 seconds. Then there will be another second stage burn at T plus 26 minutes and 19 seconds, which will last for about a minute and a half. And then finally, it will coast for almost 4 hours before doing a third burn, which will last about 30 seconds. And then finally, after that third burn is over, they'll coast for 10 more minutes before deploying the payload at T plus 4.5 hours. And again, that very long mission profile is why we see that gray stripe on the second stage. So that's going to help make sure that the RP1 in the second stage stays warm throughout the entire mission. And then, of course, the second stage also has additional COPVs on this mission as part of that mission extension package, so that they have a lot of helium, not only helium and a little bit of nitrogen, if I recall correctly, which is used for both all of those engine restarts and then also for propellant settling, since they need to maintain attitude control and then settle the propellant ahead of those 3 burns. So the second stage has a lot of work to do on today's mission, and SpaceX needs to make sure that it works nominally during that entire thing, and that's what this mission extension package is for.
It will be a long couple of hours for the SpaceX team to do their work to get their customers' package delivered to where it needs to be. And as we count down here, I do want to thank some folks, including RC Horseman, for gifting 10 Red Team memberships. Thank you very much for supporting the work that we do. Also want to thank Nigel Tocknell for 5 Red Team membership contributions and Stephen Kalovic for another 5 as well. So thank you very much for those contributions, and congratulations to members of our community who are just tuning in and getting those memberships. They're really great things to expand some of the offerings that we have here at NSF for covering spaceflight 24/7. We are on this 24 hours a day, 7 days a week, with cameras in Texas and Florida, keeping an eye on all the developments in spaceflight, and we love doing it and bringing it to you. And we talked a lot earlier in the day about the trajectory, Trevor, but maybe we should bring it up again just to see if where people might be able to see it. I guess it's heading due east this time. And Jonathan in the UK was wondering if he'll be able to see it. I don't think so, but I'll defer to you.
No, it's going more down toward the equator. So one thing, for these missions, unfortunately, we don't have pre-launch TLEs, so we don't know the exact path that it's going to take to reach its initial orbit, which is also unknown. But one thing that we do know is it's going to be going due east, and then it's going to be doing a pretty substantial inclination lowering burn throughout throughout one of its burns, probably early on in second stage flight, but we don't know for sure. And what that will do is basically try to get the inclination to, like 10 degrees, somewhere in there, would be my guess, since that will help reduce the amount of change that the satellite needs to actually do. So that unfortunately means it will not be going over the UK at all.
So there you go. So you won't be able to see it, but you can stay on the stream because we're going to get a great view of it on the way up and on the way back down, where those two boosters will be coming into where Sawyer is currently located. Sawyer's still having some bandwidth issues out there, but he is on site. We should get some great views from him at some point as the boosters come back. So we will keep an eye on things here from our studio locations. And if you're just tuning in, one of the things that we don't see too often are launches of Falcon Heavy, which are essentially 3 Falcon 9s strapped together, although the center core, of course, is a little bit beefier from a structural standpoint. And what this package today is the GOES-U weather satellite that will be going into geostationary orbit. That will be dramatically improving the weather data that we receive here on the ground, and there will be many folks that will benefit from that. And we heard from a meteorologist a little bit earlier who is super excited about all the new capabilities that this platform will provide, including better imagery, a lightning mapper, the ability to also monitor the sun and space weather all in a single package, even emergency communications that we heard from Sawyer earlier out at sea. It'll be listening for those EPIRB devices that go off when people are in danger on the oceans. So there's a lot here that this satellite will be delivering, and Falcon Heavy is the rocket to do it because it can handle those big payloads. So this is dramatically more powerful, Trevor, than a Falcon 9 alone, obviously. There's
Yeah.
3 of them strapped together.
Stage 1, fuel load complete.
Yeah, and 3 times. Oh, there's confirmation that RP1 load is complete on stage 1. Then we also had confirmation. Yep, there it is. That GOES-U is on internal power. So all things we want to hear for a launch in 8 minutes.
All right, so we are keeping an eye on things, and we've got a lot of folks on the ground. Even though we're not hearing from them today, they are on the ground to capture this launch. So don't worry, we've got all sorts of great video to show you, and we'll have audio too once this lifts off. And it's pretty loud. I've been to a Falcon Heavy launch, and it is. If you can make it to one, I would suggest definitely getting out to one. I've actually seen one up close, which was the ArabSat back in 2019. But over the holiday break, I was in Palm Beach, Florida, where I got to see it from Palm Beach, and it's still pretty
Positive
pretty
Y, fuel load
substantial.
complete.
Right? What was that call?
It sounded like PY, fuel load complete.
Okay. And it looks like they confirmed for each booster.
Yeah, so the center core was the last call out of first stage, and then now they're talking about the boosters, which I believe they just confirmed PY, and MY is the only one that is still being loaded with RP1 at this point.
Right. So we are making our way on the fueling side. The HAL 9000 here is a question. Sorry, go ahead.
No, I was going to say, this is just a reminder to people who are just now joining us. This, coincidentally, will not, if it goes today, will not be the only Falcon Heavy launch on June 25th. SDP-2, the third Falcon Heavy mission, also launched on June 25th, coincidentally. So this is not the first time we've
Negative
had
Y, fuel load complete.
Falcon. Oh, there is the NY core, also called MY sometimes for -Y. This is not the only Falcon Heavy that we've had on 39A fueled on June 25th. And the other one was basically exactly 5 years ago.
Wow. They don't fly often, so it's great to catch them while you can, which is why you definitely want to stay tuned because these launches are pretty spectacular. And I got a question from Hal 9000 about the triple sonic booms the booster makes on re-entry. I don't think it's triple. I think it's double, but I'll defer to you on that, Trevor. I've heard them. I hear a boom, boom, and a boom, boom, so I counted 4. And that's because there's a sonic boom off the top and the bottom, if I'm not mistaken.
So my understanding is that there are 3. There's one
Is
from
there?
Yeah, so what I've heard, I've obviously never heard one, is that there's one from the engine section, there's one from the landing legs, and then there's one from the grid fins. However, I think the first 2 are so close to one another that it kind of sounds like one.
Okay, got it. That would make sense. And it's pretty amazing when you're standing under them to hear that boom as they come in. Even one booster is pretty cool, but to have 2 come back is always amazing. And you know, when we were talking earlier, the timing of the landings, you know, I thought SpaceX had made some changes to it because they do space them out a little bit more than they have on prior missions that I've seen, but apparently it's just conditional.
Falcon Heavy tank.
Yeah, so
pressurizing
that's
for
what
strong back, retract.
There's another call out. Shortly, we will be seeing that strong back, which is now kind of on the right of Falcon Heavy, retracting by 1.8 degrees. So they're pressurizing the tanks to make sure that the vehicle is structurally sound for when they remove some of that support. Again, this is the fallback TE design. So once they reach T-minus 2.7 seconds and begin igniting all 27 of those Merlin engines on the first stage, that TE will start throwing back more. So it'll go to well past 45 degrees away from the vehicle to get as far away from the power of those 27 Merlins as possible.
I imagine there's probably a good amount of refurbishment that has to happen to that thing
NLM,
too.
it's the LD on the NLM net with a final status check.
Here we go.
LD,
Yeah,
everything
so
looking good on
our
our end.
understanding,
Copy that. Thank you.
that's what we want to hear.
All right.
LD
Countdown.
saying everything's looking good on their end. Again, the final SpaceX launch director go for launch will not occur until the T-minus 45 second mark.
Countdown 1. LD. NASA, go for launch.
So there is NASA's confirmation that they go for launch, but that is not SpaceX's. SpaceX has the
Right.
final
lock those complete.
go for launch again at T-minus 45 seconds.
The payload is ready, but now we need to make sure the rocket's ready. So that's the SpaceX call. Just like the fuel,
and we
it's
also
load and
just
go.
heard the we also just heard I believe that was the PY core is fully filled with liquid oxygen.
So at this point, we're ready to go. 3 minutes down to the launch of the Falcon Heavy with GOES U on board, a completely new set of Falcon 9 boosters. We'll hopefully get 2 of them back, and the center core will find its way to the ocean, where it will spend out the rest of eternity.
Load complete.
And right,
There's
Stage
the
1 is
center
ready.
core. That was center core LOX load is complete, so I believe it's just one of the side boosters remaining. I couldn't quite hear if it was PY or MY that they said was complete, so I assume it's MY that is left.
All right. And I want to thank Don and VA for your super chat right before we get to the countdown here. A lot of activity will be happening in the very near future, so thank you for your support so that we can bring this to all of you. And we didn't think we'd get here today, Trevor,
Stage
with the
2,
weather, but the
LOX
weather
load
cleared
complete.
out.
No, we didn't, but there is confirmation that the vehicle is fully filled with liquid oxygen in RP1. So all 3 of those stages of the first stage boosters are filled, and the second stage is filled. So the next event will be at T-minus 1 minute, wherein the vehicle will enter what is known as startup, which is when the vehicle takes control of the countdown. So right now it's all ground computers, but they want to transition that to the vehicle. Also at that time, the tanks will further pressurize themselves for launch. So they try to
Ground
get those to
close up.
high pressure to make sure they're very rigid for when those 27 Merlins fire up. Then again, T-minus 45 seconds is when we will get confirmation that they're go for launch from the launch director.
Here, lots of venting. We're getting close here. A minute to go. A minute and change.
Yeah, for SpaceX's 10th Falcon Heavy. This is I'm so excited.
Me too. I always love watching. Whatever it is about Falcon Heavy.
Falcon Heavy is in startup.
All right. 10 seconds to the go. Hopefully.
Yeah.
All right, we should be getting confirmation
Coming
right about
up.
now.
SpaceX
Right?
launch director, go for launch.
Yeah.
There you go. So the
That's
weather
what
is
we want
clear.
to hear.
30 seconds. And as always, we'll let you hear, without us talking over it, the beautiful sounds of this rocket.
T-minus 30 seconds.
It is something to hear. Okay, we are.
Under 30 seconds.
All right. I'm excited, Trevor. I love
Yeah,
Falcon
me
Heavy.
too. It's been a while since we've had one. Like, what, 6 months or so?
Yeah, and this one's daytime, so we can see it. It's going to be great.
Yeah.
All right, we're closing in. 5, 4, 3, 2, 1, and we'll let you listen to the sounds of the launch.
Liftoff.
Beautiful.
Engine chamber pressure is nominal.
It's amazing because it is so much larger than your Falcon 9, especially by width. And having watched shuttle, you see these go up and down. It just brings you down to
Yeah, it really does. It is so exciting to see this. And there we can see it passes through max Q. Some of the vapor cones going around. Not only the fairing on these missions, but also all of the side boosters and grid fins, which is so cool to see. Yeah, the vehicle's now past max Q, where stresses on the vehicle are highest, and going toward booster separation, which booster engine cutoff will begin at T plus 2 minutes and 25 seconds, and then the side boosters will separate at T plus 2 minutes and 28 seconds.
now we're seeing that plume expand, and it does look like a fiery Falcon, doesn't it?
Yeah.
Much more than you see on a Falcon 9. And this was kind of what I saw from Palm Beach a few months ago for that night launch. It just expands out so much more dramatically given the number of engines there. And I know we had some audio issues there, but what I did hear was the excitement of people screaming as the rocket lifted off. And this is exactly what it brings out in people. It's just amazing seeing these things lift off, especially ones this substantial.
Yeah. So now you can really kind of see during this phase of flight, especially earlier, how throttled down that center core was. So again, from John Edwards, we learned that went down to 43%, and there
Booster
we
separation
have
confirmed.
Wow.
Yep, there's booster shutdown
And back
and
chill.
separation. Oh,
Never
so now
gets
those
old.
boosters will begin their Boostback burns
EY,
to
NY,
take themselves
Boostback
back
startup.
to the Cape. So there you can see both of those are now boosting back to Cape Canaveral, where they will be attempting simultaneous landings on LZ-1s and LZ-2. If successful, that will be the 249th and 250th
All vehicles are
consecutive
following
booster
nominal
landings, which is
trajectories.
crazy.
Wow. And they're flying back to Sawyer. He's waiting for him on the other
They
side.
are.
They literally are flying back. Like they light their engines and come back to the launch site. And that's what we're watching right now. So you'll see those engines burning there on both boosters. They'll extinguish themselves in a few seconds here, and then they will coast their way back to the ground before they light up again to slow down, and then light up again when they make that landing burn. And Trevor, one of the things that's always amazed me in watching these landing burns is that they calculate, what amount of fuel they need, when to light, right down to the second, so you don't waste any weight on these. And it's almost scary watching these come back down, because just when you think it's past the point of no
NY
return,
Boostback
it
shut
suddenly
down.
lights up and slows down. Amazing.
TY Boostback
Yeah,
shut down.
for sure. So now we're coming up on a series
Nico.
of events. As you can hear,
Stage separation confirmed.
the both Boostback burns shut down, and now here we have stage separation of that center
And that
core
ignition.
in stage 2. And there's successful MVAC ignition. So once again, those are the last views we are going to see from that center core. It did its job, and it will now be splashing down in the ocean. But we have a successful stage 2 on orbit. And again, those 2 side boosters are coming back to the Cape. Their boostback burns are complete.
Fairing
That was
separation
done with
confirmed.
3 engines. There they
That's our
are. You
booster.
can see some of
Yeah.
those RCS pulses coming out for attitude control. The next burn will be the entry burn, which we're expecting to be probably just a single engine for this mission, but we'll have to see for final confirmation. And then again, the landing burn will be the 131 staggered configuration.
And I didn't see a
Also,
stiffener.
Alex pointing out.
Yep.
Yep. I was.
And so usually we see a stiffener for that second stage, not on this one.
Yeah, so this is pretty standard these days. Every Starlink mission, we've been seeing this, and even on some customer missions. So I think we can now safely say the stiffener ring is no more.
That's it. And you know what? If you can shed the weight, shed it. It's one less thing to worry about. And I think that's kind of what the Starship philosophy is, which is to have as few things that have to change states, as you mentioned earlier, as possible. And if you can take it out and don't need it, get rid of it. So here we
Yeah.
are watching one of the 2 boosters come back down, I think, right? I don't see the other one in this shot.
Yeah.
Stage 1 FTS is saved.
All right, so we're going to keep an eye on these boosters. They're coming back to Sawyer, who's out in the field waiting for their arrival. And for the most part right now, Trevor, it's just falling.
Yeah, so it's just letting gravity do what gravity does best. It's canceled out all of its downrange velocity and has velocity to come back. So right now, if nothing was to happen, these would just splash down right outside, right offshore in some pre-designated landing recovery areas that's closed off just in case something goes wrong. But all is looking good so far for the entry burn, which we are expecting to begin here in just a little bit at T plus 6 minutes and 36 seconds. So any second now.
And generally around this time, the booster
There it is.
Entry burn.
Nuts. Okay, so it is a 1-3 entry burn. You could see it started off kind of circular shaped, and now it's a clear line of those 3 engines. So this means that landing burn is probably going to be a single engine if I was to.
burn shut down.
What's amazing is we're looking at this pretty much from directly underneath.
PYNY FTS is saved.
So FTS is saved on both vehicles as they continue gliding until their landing burn. Again, that landing burn is expected to start at T plus 7 minutes and 53 seconds. So here in about 30 seconds, we should see the start of that burn and hopefully a simultaneous landing on LZ1 and 2.
LZ1 and 2, well, look at that. It just can't. It came out of nowhere. And that's what happens, right? It's just like you're looking for it, and suddenly there it is. It's just dropping down. And you can see.
And here you can
Stage 2
you can
FTS
really
is saved.
see the vehicles at an angle, trying to use its body to just generate the tiniest bit of lift. Wow, this is a cool shot.
That's a really cool shot.
landing
And
burn.
there it is.
Stage 2 is in terminal guidance.
It's so hard to track these. There we go.
Yeah.
There's the landing burn. Coming down pretty close to answer this time. Yep.
Yeah. There's one. And there's 2. That's never gonna get old.
Nope.
So that was SpaceX's 249th and 250th consecutive landings, and in terms of total landings, that was landing number. Oh boy, I don't have it in front of me. Give me 1 second.
They've been pretty successful in remember how hard it was to get to that first one, and
Nominal
now,
orbit insertion.
right.
Yeah, 323
news.
and 324 total landings. Wow. That was crazy.
And we just had a call out for a nominal orbital insertion, which is the first, I would guess, a parking orbit, if you will, because there will be some coasting in orbit before the next burn that has to take place. And this is a 4-hour process until this mission is completed. And as much as we love covering these things, we're not going to stay on for the whole 4 hours, but you can follow us on our X feeds and Facebook and other places and YouTube here for updates on the mission as it progresses. But there is 2 boosters that were once shiny and new. I could see how sooty they are from here. So they've got their first return flight there, and the soot to show for it. And these will be recycled. They'll be sent back up again, maybe as just standalones. So coming to a Starlink mission near you.
It seems unlikely to me that they get turned into a Falcon 9. They have a pretty large Falcon 9 fleet. And we've only seen them do this like basically once with Block 5. But we'll have to see. It's definitely a possibility and something that SpaceX designed Block 5 to be substantially easier to do, is swap between single core config and multi and Falcon Heavy config.
I can tell you everybody got quite a show down there. I don't know if we have, I don't think Sawyer's bandwidth is improved, but I'd be love to hear from him if we're able to at some point. But there you go. There's the Pad 39A. The strong back is venting. Everything is mostly intact there. So the refurbishment begins, and they have to get ready for the next mission. They're turning missions around pretty quickly these days.
That they are, right? This was already SpaceX's 67th launch of 2024. So 2 of those are Starship. So 65 Falcon missions so far is just kind of insane. The year's not even half over.
Right. It used to be like once a quarter, if that, and now it's like it's keeping us busy. And when we launched Falcon, or when SpaceX launched Falcon Heavy the last time, a Starlink mission followed. So it was like not even hours from one to the next. Of course, they were coming from different pads. But I was down in Palm Beach. I saw Falcon Heavy, and then a few hours later, watched Starlink go up. So pretty cool stuff. We have a super chat that came in during the launch from Regal Meh, who says, "You guys rock with these views. Some great tracking. Absolutely, some great tracking." And that is something I think it was Wade that was tracking some of that. So some great work today out in the field. So thank you for the super chat, and the contributions help keep it going. So that's how we operate here. So this is all a community effort here. So there we go. And those payload fairings are probably still on the way down, Trevor, right?
Yeah, so those payload fairings typically splash down about 45 minutes after launch. So they're obviously substantially less massive than the boosters, while having a substantially greater surface area. So the atmosphere just really slows them down, and then the final bit is done under parachute, which slows it down even more.
I saw some video from a fishing boat where they happened to be right underneath one of those as they came in. So they do come down pretty gracefully, not as violently as the rockets do. So pretty fun to watch that. But yeah, it's always good to see an empty pad with a so far successful mission. We got both boosters back. We have a nominal orbit insertion, at least for the first part of this mission, of the GOES-U satellite. I know a lot of you who are involved with meteorology are very excited about the new benefits that this satellite will offer. And for those of us who are not meteorologists, we do benefit from knowing what the weather's going to be like with much greater accuracy. So this is one that's really going to benefit all of us here on Earth and beyond, because it also tracks space weather. So the next step for this is there's a coast phase, and then in about 4 hours, we're looking at the final boost to its orbit, where it will begin operations. So this looks like a pretty smooth Falcon Heavy flight, Trevor.
Yeah, I mean, it's looking good so far. Of course, almost all of the state changes that we talked about, that's in the past, which is good. However, the second stage has a lot more work to do. Right, there are 2 more burns coming up, and payload deploy is not for another 4 hours and 15 minutes. So it's there's a second stage, there's a lot more to do for sure.
Yes. So we will keep an eye on things, and we'll keep watching as time goes on here. We'll stick around for a little bit longer. Let me ask you this question. This came in from the chat from Creative Bytes, who wants to know, do the 3 engines or the 3 boosters have to be precisely timed to ignite at the same time to make the launch stable? I would imagine it has to be very much in sync for everything to go smoothly, given how you have it spread across 3 boosters.
Yeah, so on each individual core, they are ignited in pairs, opposite of one another, to help reduce transients on the vehicle. However, in terms of the core ignition process, I'm not sure if we know which ones go first. I know, for example, on Delta for Heavy, one of the side cores ignites at the same time as the center core, and then this other side core ignites later. So you actually kind of have this weird torque on the vehicle. I'm not sure if Falcon Heavy is the same. I don't think it is, but I may be wrong. But no matter what, you have all of those ground clamps for a reason that can help prevent, even if there is a little bit of torque on the vehicle. But of course, you want to try to minimize that.
And we got a super chat question here from Christopher Campfield, who wants to know, do you think these will be the same boosters used for the Europa Clipper mission in the future? And it's possible, right? I mean, they get these boosters back for a reason, and if they are going to be on Falcon Heavy duty, it's potentially possible, depending on the condition that they came back in, that they will be used for that one, right?
Yeah, I think Europa Clipper is using SpaceX's other set of boosters, B1064 and B1065, since they want to expend ones that have more launches under their belt. However, that could easily change, and I could easily be incorrect.
We'll keep an eye on the booster assignments as we get closer to that mission. And we've got a couple of a photo from the field. I think Julia's got one here of a awesome streak photo going up there. That looks awesome. Of the Falcon Heavy lifting off from pad 39A. Good stuff. Cool.
Very good stuff.
Yeah. So you got some great photos out there in the field. And I don't even, we asked Max earlier how many launches he's seen. I think Julia's probably seen more. So, yeah, we've got a great team out there. We'll have plenty more images coming in the near future. So stay tuned for that. And I think we'll have some great photos up on our social media sites in a little bit too. I'm seeing some previews of them in the back channel here that aren't ready to get posted just yet, but we've got some great stuff. So stay tuned. So in case you're just tuning in, Falcon Heavy has launched. The 2 boosters returned successfully. We are in a successful parking orbit at this point, waiting for the next stage of this mission to begin. And it will take about 4 hours and change to get everything to where it needs to be. But what was launched today was the GOES-U weather satellite, which is on its way to its service orbit, which will be a geostationary orbit. But in the meantime, it's taken a trip around the world. Right now, on its way to the coast of Africa. And when it gets back to where it needs to be, they light up the second stage a couple more times. And there you go. You will have yourself a new weather satellite that will give you much more accurate weather predictions, which I think we might need. Because remember, Trevor, when we started, we were at 30% of favorable weather predictions here and ended up being 100. We got off the ground. So,
yeah.
That's it.
Yeah, for sure. And definitely way more launches to come. The next one that NSF will cover is, of course, the Firefly launch from the Cape. And then more Starlink launches with the Starlink launch on Thursday. And then a mission from Vandy on Friday, which we won't be covering, unfortunately. But SpaceX's launch cadence is just crazy.
It is. It's keeping us busy, but you know what? Everybody loves watching it, and that's why we bring these things to you. So that is what we shall do, because we are NSF, and we cover the rocket launches, so it's good stuff. So we are T plus now 18 minutes and 18 seconds, as you can see on the NASA clock there at the Kennedy Space Center. Everybody's picking up their cameras and stuff, but that is looks like it's it for what we can see from the ground. And of course, we're waiting on the GOES satellite and the second stage of this launch to make its way around. So Yes, so I think we are nearing the end of our stream here, but I want to thank everybody for tuning in. And we've got a lot of people to thank today because even though you heard mostly Trevor and I, we had a lot of other folks contributing to the effort today. So let me make sure I don't miss anybody here. So we had Max at the earlier part of the stream here on top of the hut. We had Sawyer, who got a great show, I am sure, underneath those two boosters as they came back down. Also out in the field is D. Wise and Wade and Julia. And, of course, my buddy Trevor here, who's been chatting with me and dropping some really good knowledge on all of us. And we have Jay Keegan and Carson, who were behind the scenes, pushing all the buttons and making this stuff work today. That is a hard job, probably harder than launching rockets these days. So thank you all for your contributions to that. And that is going to do it for us for now. But be sure to check out the NASA Spaceflight store at shop.nasaspaceflight.com and pick up some cool space-related goodies for you and your loved ones. Good stuff there as well. So until next time, that will do it for this coverage of Falcon Heavy. But stay tuned. More rockets are launching before you know it. So be sure to subscribe, and we'll see you next time.
And here we go. We have liftoff. Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, planet.
Water towers fly! Yes! Tango down to nominal.
Flight downside FD off. Bring in FD off. Off. It's orange!
Oh my god! Oh my god!
Decollage.
What is it?
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.